Good morning, students. So, next period you will be having mathematics class. Now, let us continue the regular chemistry class, that is solid state. So, in the previous class, I think we have discussed some important concepts related to closed packed structures. Okay. So with respect to closed packed structures, we have discussed closed packed structure in one dimension, similarly we have discussed closed packed structure in two dimension, and we started discussion about closed packed structure in three dimension. Okay. So closed packed structure in one dimension, there is only one possibility. I have also shown the model of that is closed packed structure of one dimension. This is arrangement of particles in one dimension. So only one way is possible. And here one important thing you should remember, that is coordination number. So what is the definition of coordination number? Number of nearest neighbors of a particle, NQ, is called coordination number. And closed packed structure in one dimension, coordination number is 2. Similarly, closed packed structure in two dimension. So closed packed structure in two dimension, we can have, that is two types. One is called square closed packed structure in two dimension, and second one is hexagonal square, that means hexagonal closed packing in two dimension. So in two dimension, two ways in which, that is, spheres can be arranged. So one of the type of two-dimensional closed packing arrangement of particles, it is square closed packed structure in two dimension, and another type, it is hexagonal closed packed structure in two dimension. About this also we have discussed. So in case of square closed packed structure, coordination number will be 4. One dimension coordination number is 2. And in case of two-dimensional closed packed structure, square closed packing in two dimension, coordination number is 4, whereas hexagonal, that is closed packed structure, coordination number will be 6. Okay. So about this we have already discussed in detail in the previous class. Now coming to, that is closed packed structure in three dimension. So how actually we can get closed packed structure in three dimension? Closed packed structure in two dimension is obtained by arranging the layers of closed packed structure in one dimension, one above the other. In the same way, closed packed structure with respect to three dimension, it is obtained by arranging the layers of closed packed structure in two dimension, one above the other. So two-dimensional closed packed structure layers ಏನಿರುತ್ತೆ ಅವುಗಳನ್ನ ಒಂದರ ಮೇಲೆ ಒಂದು ಅರೇಂಜ್ ಮಾಡ್ತಾ ಹೋದ್ರೆ the closed packed structures what we get, it is nothing but three-dimensional closed packed structure. So with respect to three-dimensional close packed structure, so what are the possibilities? See, first is three-dimensional structure from two-dimensional close packed arrangement. It can be obtained, that is from square close packed structures. So when we arrange the layers of square close packed structure in two dimension, one above the other, we get three-dimensional close packed structure. So from square close packed structure, we can get three-dimensional close packed structure. So when layers of square close packed structures, when they are arranged one above the other, we get three-dimensional close packed structure. Let us take the model to understand that one. See, this is, say, example for three-dimensional close packed structure which is obtained from two-dimensional close packed structure. So square close packed structure in two dimension, when layers are arranged one above the other. See, here we are following the same method. So spheres of, that is one layer of square close packed structure is placed exactly above the spheres of, that is first layer. So spheres of second layer, they are aligned exactly on the spheres of the first layer. So when we go on arranging, that is many layers of square close packed structure in two dimension, so we get, that is close packed structure in three dimension. So this is one example model to show three-dimensional arrangement. And here you can see the layers or arrangement of spheres in different layers, it is same. That's why the pattern which is obtained, it can be called as A pattern, because in layer A, layer B, layer C and so on, the arrangement of spheres is same, it is not different. That's why the pattern which is obtained with respect to close packed structure in three dimension from square close packed structure in two dimension, it is called as A type of pattern. And here you can see the three-dimensional arrangement of particles which is obtained by taking the layers of square close packed structure in two dimension, one above the other, we get simple cubic lattice. So this is the simple cubic lattice, that is a three-dimensional arrangement which is obtained, that is when many layers of square close packed structures, they are arranged one above the other. So simple cubic lattice three-dimensional structure is obtained from square close packed structure in two dimension. When layers of square close packed structure in two dimension, when they are arranged one above the other, we get the three-dimensional arrangement, which is nothing but simple cubic lattice. And what is the unit cell that is obtained in simple cubic lattice? You can see this is three-dimensional arrangement, and if you take the smallest portion of this cubic lattice, the unit cell, it is primitive. So in simple cubic lattice, that is three-dimensional arrangement, the unit cell is primitive unit cell. So this is one example for three-dimensional, that is close packed structure, which is obtained from two-dimensional, that is close packed structure. Okay. Similarly, so the second type of arrangement which is possible in close packed structure in two dimension, it is hexagonal close packed structure. So hexagonal close packed structure in two dimension. Square close packed structure in two dimension, hexagonal close packed structure in two dimension. What is the difference? In case of square close packed structure in two dimension, layers of that is spheres which are present in different layers, they are placed exactly one above the other. But in case of hexagonal close packed structure in two dimension, spheres of the second layer, they are placed in the depressions of the spheres of the first layer. Staggered manner it is called as. Okay. And since the layers are arranged differently, the pattern which is obtained, it is termed as AB pattern. And coordination number will be 6. And very important, when that is second layer of spheres, when it is placed in the depressions of the first layer, those two layers will not match with one another. That's why they are given the that is representation, different representation A and B. But if you place the third layer over the second layer, then alignment of spheres in third layer is same as alignment of spheres in first layer. Similarly, if you place the fourth layer, alignment of spheres in fourth layer is same as alignment of spheres in second layer. That's why the pattern is called as AB pattern. And very important, when that is layers of one dimension, when they are arranged one above the other in such staggered fashion, there you can find that is some gaps between constituent particles. See, the gaps between constituent particles, it is called as voids. Void is nothing but space. So space which is present between the spheres or particles, it is called as void. And in case of hexagonal close packed structure in two dimensions, the voids which are generated, they are triangular in shape. So the voids are called as triangular voids. Okay. So this is one more point I have to remember with respect to hexagonal close packed structure in two dimension. See, if you observe square close packed structure in two dimension, hexagonal close packed structure in two dimension. In case of square close packed structure in two dimension, the space between the spheres is larger. Voids are larger. Whereas in case of hexagonal close packed structure in two dimension, the space between the spheres is lesser. So during the arrangement of constituent particles in crystalline solids, if the percentage of that is space occupied by the particles is more, then it is said to be efficient crystal. So percentage of voids must be less. So if you compare square close packed structure in two dimension hexagonal closed pack structure in 2 dimension, which is more efficient. Hexagonal closed pack structure in 2 dimension is more efficient because in this case, when particles are arranged, the percentage of space that is present will be less compared to that is square closed pack structure in 2 dimension. So from square closed pack structure in 2 dimension, by arranging the layers one above the other, we get simple cubic lattice. In the same way, when hexagonal closed pack structure in 2 dimension, when layers of hexagonal closed pack structure in 2 dimension, when they are arranged one above the other, then we can get that is 3-dimensional closed pack structure. So let us see what are the types of 3-dimensional closed pack structure we can get by arranging the layers of hexagonal closed pack structure one above the other. Okay. So first let us take one layer of hexagonal closed pack structure in 2 dimension. See here, that is spheres of the second layer, they are placed in the depressions of the spheres of the first layer. Similarly, third layer. This is third layer and fourth layer. Okay. Yes. See, this is layer A. Alignment of spheres in second layer is not same as layer A. That's why it is represented as B. And if you take the third layer, the alignment of layer 3 and layer 1, it is same. That's why it is called as A. Similarly, if you take fourth layer and second layer, alignment will be same. That's why the pattern is called as ABAB pattern. And here you can see these are called as actually voids. And if you observe the shape of the voids, they are triangular in shape. Okay. See, these are called triangular voids. And if you take that is different layers, the triangular voids, apex of triangular void, it is not same. In one layer, apex of the triangular void is upwards, whereas in another layer, apex of the triangular void is downward, like this. Okay. So the triangular voids which are created, they are not same. In one layer, apex is pointing upwards. In another layer, apex is pointing downwards. See here, apex is pointing upwards in this layer. Apex of the triangular void is facing upwards, whereas in this layer, apex of the triangular void, it is facing downwards, like this. Okay. But in general, we can say when that is hexagonal closed pack structure in 2 dimension, when it is obtained, we get triangular voids. Okay. So in order to get 3-dimensional structure, by starting with hexagonal closed pack structure in 2 dimension, this is layer 1. Okay. And we have to place the second layer over this first layer. See how actually we can place the second layer over the first layer. That is very important. So first case, placing second layer over first layer. So same type of, that is hexagonal closed pack structure in 2 dimension we have to take, and that should be placed over this layer. This is first layer. Same type of layer, second layer must be placed over the first layer. So how actually that can be done? See, when second layer is placed over the first layer, all the triangular voids will not be occupied by piers. See, in first option, what happens? Piers of the second layer, they occupy triangular voids. So triangular voids will be occupied by piers of the first layer. Say for example, I'll take only 3 piers so that you can understand. So this is the triangular void. I'm taking part of it. Okay. And when second layer is placed, pier of the second layer, it occupies the triangular void like this. So when second layer is placed over the first layer, in some places you can see that pier, this is pier of second layer and these are piers of first layer. Pier of second layer, it covers the triangular void. See, such void which is generated when pier of the second layer is placed over the triangular void, it is called as tetrahedral void. So why actually it is called as tetrahedral void? See, it is called as tetrahedral void because if you actually join the centers of these 4 spheres, so this is one sphere, let us take the center of that sphere, and this is the center of another sphere, center of one more sphere, and this is center of one more sphere. So if the centers of these 4 spheres, if they are joined, then we get a tetrahedral. That's why the void which is generated when second layer is placed over the first layer, wherever the sphere of the second layer occupies the triangular void, then there tetrahedral void is generated. Okay. So this is one possibility. Similarly, when the second layer is placed over the first layer, in some places, piers will not occupy the triangular void, whereas the triangular void of the second layer, it overlaps the triangular void of the first layer. How that can be shown? Okay. So this is the triangular void which is generated. So this is first layer. So in some places, when second layer is placed over the first layer, arrangement will not be like this. So here tetrahedral void is generated when pier of the second layer, when it actually covers the triangular void. But in some places what happens, when second layer is placed over the first layer, triangular voids of the second layer, it actually overlaps the triangular void of the first layer. But those 2 triangular voids will not coincide with one another. Yes. See here, these are the spheres of the second layer. And here you can see so in case of first layer, triangular void apex is facing downwards. In case of second layer, triangular void apex is facing upwards. So that means they do not exactly coincide. So triangular void of the first layer, if it is facing downwards, triangular void of the second layer, it will be facing upwards. So in some places, this type of void will be generated, and such voids are called as octahedral voids, which is represented as O. Okay. So why it is called octahedral void? So if we join the centers of the six sphere, it actually produces octahedron. This produces tetrahedron. That's why it is called tetrahedral void. Whereas six spheres, centers, if they are joined, it produces octahedron. That's why it is called as octahedral voids. Okay. So very important. When second layer is placed over the first layer of hexagonal closed packed structure in 2 dimensions, how many voids are generated? Always we can expect the formation of 2 types of voids. One is tetrahedral void and another is octahedral void. So how tetrahedral void is generated? Tetrahedral void is generated when the sphere of the first layer, when it occupies the triangular void of the first layer. Similarly, when octahedral voids are generated, that is when the triangular void of the second layer, when it covers the triangular void of the first layer. So when second layer is placed over the first layer, in case of hexagonal closed packed structure, 2 types of voids are generated: tetrahedral voids, octahedral voids. Very important. How many tetrahedral voids and how many octahedral voids are generated when a 3-dimensional structure is formed, when a crystal lattice is formed? That you have to understand. Okay. So this is very important. See, number of tetrahedral voids or octahedral voids, it depends on number of closed packed structures. Number of tetrahedral voids and octahedral voids depends on number of close packed structures. So this is important. How many tetrahedral voids and how many octahedral voids will be formed when a crystal lattice is generated? That depends on number of close packed structures. Suppose if we take number of close packed structures, suppose if we take number of close packed structures as n, I'm not taking any number, I'm taking that as n. N number of close packed structures are formed in a crystal lattice. In such case, how many tetrahedral voids and how many octahedral voids will be generated? Very important. Number of octahedral voids. number of octahedral voids produced are equal to number of close packed structures. Suppose if n number of close packed structures are formed, same number of octahedral voids will be generated. That means n only. For example, say in a crystal lattice, number of close packed spheres are 100. So how many octahedral voids will be generated? Same as number of close packed structures, that is 100 only. ಎಷ್ಟು ಕ್ಲೋಸ್ ಪ್ಯಾಕ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಫಾರ್ಮೇಶನ್ ಆಗುತ್ತೋ ಅಷ್ಟೇ ಆಕ್ಟಾಹೆಡ್ರಲ್ ವಾಯ್ಡ್ಸ್ ಜನರೇಟ್ ಆಗಿರುತ್ತೆ. ಓಕೆ, ಸೊ ನಂಬರ್ ಆಫ್ ಕ್ಲೋಸ್ ಪ್ಯಾಕ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್, ಇಫ್ ವಿ ಟೇಕ್ ದಟ್ ಆಸ್ n, number of octahedral voids generated is also n. What about number of tetrahedral voids? Number of tetrahedral voids is twice the number of close packed structures. So if close packed structures are n, then number of tetrahedral voids will be equal to 2n. Suppose if number of close packed structures or spheres are 100, how many tetrahedral voids will be generated there? 2 into 100, 200. Okay, see, question can be asked. In a crystal lattice, number of close packed spheres are 100. How many octahedral voids and tetrahedral voids are produced? So number of octahedral voids will be same as number of close packed structures. Number of tetrahedral voids are twice the number of close packed structures. So if close packed structures are 100, octahedral voids 100, tetrahedral voids will be 200. Total number of voids, octahedral voids plus tetrahedral voids, that will be 300. So during close packed structure, always we can expect two types of voids. One is octahedral void and another is tetrahedral void. Okay, so that is produced when second layer is placed over the first layer with respect to hexagonal close pack structure in 2 dimensions. Very important. Based on this, you can expect problems. We will work out what type of problems you will get with respect to close pack structures and octahedral voids and tetrahedral voids. This relation you remember. Number of close pack structures, if it is n, octahedral voids same as close pack structure, that is n. Tetrahedral voids twice the number of close pack structure, that is 2n. So this is with respect to arrangement of second layer over the first layer. And similarly, next is so placing third layer over the second layer. So we have discussed when second layer is placed over the first layer of hexagonal close pack structure, what are the types of voids that are generated and what is the relationship between those voids and number of close pack structure. See, we have already placed 2 layers and above that we are placing one more layer, that is third layer. So how we can place the third layer over the second layer? See, when first layer is formed, voids are triangular in shape. And similarly, when second layer is placed over the first layer, the voids generated are called tetrahedral voids and octahedral voids. How we can place the third layer over the second layer? There are 2 possibilities. One possibility is when Third layer is placed over the second layer. Spheres of the third layer, they can cover tetrahedral voids. So spheres of the third layer, they are placed in such a way that those spheres, they are covering tetrahedral voids. I'll show the model here. See, this is the first layer which is containing, that is, voids in triangular shape. Here you can see voids are in triangular shape. This is first layer. And above this first layer, I am placing the second layer. Okay. So when second layer is placed, the arrangement of layers in that is spheres in first layer and arrangement of spheres in second layer, it is different. So we can call the first layer as A. Okay. And second layer, the spheres arrangement is not same as first layer. So we can call this as B. So when second layer is placed over the first layer, as I said, two types of voids will be generated. One is tetrahedral voids and another is octahedral voids. So when actually you can expect tetrahedral void, say this is triangular void. Okay. This is triangular void. When exactly the sphere, when it covers the triangular void, then like this. So this is a sphere. See, when it covers like this. Yes. So now tetrahedral void will be generated. So why it is called tetrahedral? If you join the centers of four spheres, then you will get tetrahedral. Okay. Second layer. Similarly, how octahedral void will be generated? See, octahedral void will be generated when the triangular void of the first layer, it is occupied by triangular void of the second layer. This is second layer. It is also having triangular void. So when the triangular void exactly occupies the triangular void of the first layer, like this. See, like this. Okay. So octahedral void will be generated. You can see like this. Okay. So like this it will be their arrangement. Okay. So octahedral void. Suppose after placing the second layer over the first layer, imagine both tetrahedral voids and octahedral voids will be generated. And how you are going to place the third layer? Let us take this is the third layer, and I am placing the third layer in this way. See, the alignment of spheres in third layer, alignment of spheres in second layer, it is same. That's why I can call third layer as A only. Okay. So like this, if I go on arranging, that is layers. Suppose if I arrange one more layer, is not here. So the fourth layer will be same as second layer. Again I will get B. So AB pattern of arrangement, it takes place when, that is, layers are arranged one above the other. So here in this case, tetrahedral voids are covered, and this type of three-dimensional arrangement, which is possible due to the arrangement of that is layers of hexagonal close packed structure one above the other in ABAB pattern, it results in the three-dimensional structure which is called as HCP, and HCP is nothing but hexagonal closed packed structure. Okay, so when we arrange, that is hexagonal closed packed structure in two dimension, one above the other, by covering tetrahedral voids, what is the three-dimensional arrangement we get? It is hexagonal closed packed structure. And what are the examples for HCP? So zinc and magnesium. So zinc metal and magnesium metal, they crystallizes in HCP, hexagonal closed packed structure. Okay, so this is one possibility, that is covering tetrahedral voids. So when third layer is placed over the second layer, so spheres of the third layer, they can cover tetrahedral voids, which results in hexagonal closed packed structure in three dimension. And which are the examples for that? Zinc and magnesium. Okay. Similarly, okay. ಅಲ್ಲ ಇನ್ನೊಂದು ಚೂರಿದೆ ಮತ್ತೆ ಹೊಸದಾಗಿ ಶುರು ಮಾಡೋದು 2 minutes. So second type is covering octahedral voids. So we can place the third layer over the second layer in such a way that octahedral voids will be covered. So how we can show that? See, this is first layer and this is second layer, sphere of second layer. And during this stage, both octahedral and tetrahedral voids will be generated. And I am going to place the third layer over this one like this. This is third layer. Or like this. Okay, this is first layer, second layer, third layer, and fourth layer. See, all the three layers are different. That's why pattern will be A, B, C, A, B, C, and then fourth layer will be like this. Arrangement of first layer and fourth layer will be same. So what is the pattern I am getting here? The pattern is A, B, C, A, B, C pattern. So when the third layer, spheres of third layer, when they cover octahedral voids, this is the pattern I get, ABC pattern. And this type of arrangement results in a three-dimensional structure which is called CCP or FCC. Okay. So what is CCP? CCP is nothing but cubic close packing structure. And FCC is nothing but face centered cubic, face centered cubic close packing. And which are the examples for this type? Copper and silver. Okay. So remember, when third layer is placed over the second layer, tetrahedral voids can be covered, which results in HCP. And similarly, when third layer is placed over the second layer, we can cover octahedral voids, which results in this type of pattern, and that is called as CCP or FCC, cubic close packing structure or face centered close packing structure. And examples are copper and silver. See, HCP, CCP and FCC, they are highly efficient three-dimensional arrangements. Okay. So with respect to efficiency of three-dimensional structures, we'll discuss in the next class. So with this closed packed structure in one dimension, two dimension and three dimension we have discussed. Next, when constituent particles are arranged in three dimension, how we can say the efficiency? In what type of arrangement? That is, voids, percentage of void will be less. That we will discuss packing efficiency, and also we will work out some problems related to closed packed structures. Thank you.
Okay. Good afternoon, students. ಬೇಗ ಲಾಗಿನ್ ಆಗಿ. We'll continue differentiability. Okay. See, so far we have learned differentiation of composite functions by chain rule. That is first one we have learned. Second one, if we have implicit functions, how to differentiate that implicit function? Adana tilkondidivi, right? Right. Implicit functions. Ivaga inverse trigonometric functions na derivatives tilkondvi. How to find the derivatives of inverse trigonometric functions kalkondvi. Idralli substitution method anta barutte. Inverse trigonometric functions alli we have learned definitions of inverse trigonometric function, range, domain, principal value kalli. Amen properties ide. A properties inna use ಮಾಡ್ಕೊಳ್ತೀವಿ substitution method alli. So these are the properties which we use. Actually ಇದು reduced syllabus ಅಲ್ಲಿ ಇದೆ, ಅಂದ್ರೆ deleted part ಅಲ್ಲಿ ಇದೆ. ಬಟ್ ಇಲ್ಲಿ ಈ ಸಿಲೆಬಸ್ ನಮಗೆಲ್ಲ ಬೇಕಾಗುತ್ತೆ. ರೆಡ್ಯೂಸ್ ಸಿಲೆಬಸ್ ಬಂದಾಗ ನಾವು ಅದನ್ನ ತೆಗೆದುಹಾಕ್ತೀವಿ ಅಲ್ಲಿ. ಬಟ್ ಇಲ್ಲಿ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡಬೇಕಾದ್ರೆ ನನಗೆ ಬೇಕಾಗಿದೆ. ಹಾಗಾಗಿ ಜಸ್ಟ್ ಐ ಆಮ್ ಎಕ್ಸ್ಪ್ಲೈನಿಂಗ್ ಹಿಯರ್. ಸೈನ್ ಇನ್ವರ್ಸ್ ಆಫ್ ಸೈನ್ ಥೀಟಾ ಇಸ್ ಥೀಟಾ, ಕಾಸ್ ಇನ್ವರ್ಸ್ ಆಫ್ ಕಾಸ್ ಥೀಟಾ ಇಸ್ ಥೀಟಾ, ಟ್ಯಾನ್ ಇನ್ವರ್ಸ್ ಆಫ್ ಟ್ಯಾನ್ ಥೀಟಾ ಇಸ್ ಥೀಟಾ. ಎಸ್ ಸರ್ ಮಾಡಿದ್ದಾರೆ ನಿಮ್ಗಾಗಲೇ. ಐ ಹೋಪ್ ಯು ರಿಮೆಂಬರ್. Cosecant inverse of 1 by x is sin inverse x, or cosecant inverse x is sin inverse of 1 by x. Secant inverse of 1 by x is equal to cos inverse of x. Idinne barkolak hogbedi, just listen to this. Tan inverse of 1 by x is equal to cot inverse of x, and tan inverse x plus tan inverse y is equal to tan inverse of x plus y divided by 1 minus xy. These are the formulas with respect to inverse trigonometric functions. ಫಾರ್ಮುಲಾಗಳನ್ನ ಇಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ಕೊಳ್ತಾ ಇದ್ದೀನಿ, ಅದಕ್ಕೆ ಐ ಹ್ಯಾವ್ ಮೆನ್ಷನ್ಡ್ ಇಟ್, ರೈಟ್. ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮೆಥಡ್ ಅಂತ ಬರ್ಕೊಳ್ತಾ ಹೋಗಿ. ನಾ ಹೇಳೋದನ್ನೆಲ್ಲ ಒಂದು ಡೂ ಎ ಥಿಂಗ್, ನೋಟ್ಸ್ ಅಲ್ಲಿ ಬರೀಬೇಡಿ, ರಫ್ ಬುಕ್ ಅಲ್ಲಿ ಬರ್ಕೊಳ್ಳಿ. ನೋಟ್ಸ್ ಕಳ್ಸಿದ ಮೇಲೆ ನೀವು ನೀಟಾಗಿ ಬರ್ಕೊಳ್ಬಹುದು ಲೇಟರ್ ಆನ್. ಓಕೆ, ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮೆಥಡ್ ಅಂತ ಹೆಡಿಂಗ್. ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ದಿ ಫಾಲೋಯಿಂಗ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಎಕ್ಸ್. ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ದಿ ಫಾಲೋಯಿಂಗ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಎಕ್ಸ್. First formula, y is equal to sin inverse of 2x divided by 1 plus x square. Sin inverse of 2x divided by 1 plus x square. ನಮಗೆ ಇಲ್ಲಿ ಟ್ರಿಗ್ನೋಮೆಟ್ರಿಕ್ ಫಾರ್ಮುಲಾಗಳು ಜ್ಞಾಪಕ ಇರಬೇಕು. ಇದ್ರ ಜೊತೆಗೆ ಟ್ರಿಗ್ನೋಮೆಟ್ರಿಕ್ ಫಾರ್ಮುಲಾಗಳು ಯಾವ್ದು ಅಂತ ಅಂದ್ರೆ ನೋಡಿ, sin 2 theta in terms of tan theta ಬರೀಬೇಕು ಅಂತಂದ್ರೆ this is nothing but 2 tan theta divided by 1 plus tan square theta. What I have done, I have expressed sin 2 theta in terms of tan theta. ಈ ಫಾರ್ಮುಲಾ ಒಂದಿದೆ. ಇನ್ನೊಂದು cos 2 theta ಇದೆ. Cos 2 theta is 1 minus tan square theta divided by 1 plus tan square theta. Then tan 2 theta ಇದೆ. Tan 2 theta is 2 tan theta. Same ಇದೇ ತರನೇ ಫಾರ್ಮುಲಾ ಬರುತ್ತೆ. Divided by 1 minus change ಆಗುತ್ತೆ ಅಷ್ಟೇ. So these are the formulas which we oftenly use in this substitution method. Sin 2 theta is 2 tan theta divided by 1 plus tan square theta. Cos 2 theta is 1 minus tan square theta divided by 1 plus tan square theta. Tan 2 theta is 2 tan theta divided by 1 minus tan square theta. ಇವೆಲ್ಲ ಫಾರ್ಮುಲಾಗಳನ್ನು ಗಮನದಲ್ಲಿ ಇಟ್ಕೊಂಡು ಮನಸ್ಸಲ್ಲಿ ಇಟ್ಕೊಂಡ್ರೆ ಅದಕ್ಕೆ ನಾನು ಹೇಳಿರೋದು ನಿಮಗೆ ಫಸ್ಟ್ 2 pages ಅಲ್ಲಿ ಫಾರ್ಮುಲಾ ಲಿಸ್ಟ್ ಆಫ್ ಟ್ರಿಗ್ನೋಮೆಟ್ರಿಕ್ ಬರೀರಿ ಅಂತ ಅದಕ್ಕೋಸ್ಕರ ಹೇಳಿದ್ದು. ಅದೇ ಉದ್ದೇಶದಿಂದ ಆ ಫಾರ್ಮುಲಾ ಲಿಸ್ಟ್ ನೀವು ಚೆಕ್ ಮಾಡ್ಕೋಬಹುದು. ಓಕೆ, ನಾವು ಕಮಿಂಗ್ ಟು ದಿಸ್ ಪ್ರಾಬ್ಲಮ್. y is equal to sin inverse of 2x divided by 1 plus x square. This can be easily solved in two ways. ಒಂದು ಇನ್ವರ್ಸ್ ಟ್ರಿಗ್ನೋಮೆಟ್ರಿಕ್ ಫಂಕ್ಷನ್ಸ್ ಕಾನ್ಸೆಪ್ಟ್ ಅಪ್ಲೈ ಮಾಡ್ಕೊಳ್ತೀವಿ, ಡೈರೆಕ್ಟ್ ಆಗಿ ಇದನ್ನ 2 tan inverse x ಅಂತ ಬರೀಬಹುದು. This can be applied, ಅಥವಾ this can be written as 2 tan inverse x if you are well versed with it in inverse trigonometric function. ಬೇಡ, ಇವಾಗ as usual as the heading itself is saying substitution method ಅಡಾಪ್ಟ್ ಮಾಡ್ಕೊಳ್ತಾ ಇದ್ದೀವಿ. ಏನು ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮೆಥಡ್ ನೋಡಿ, ಒಂದು ಪ್ರಾಬ್ಲಮ್ ನಿಧಾನಕ್ಕೆ ಹೇಳ್ಕೊಡ್ತಾ ಇದ್ದೀನಿ, ಅದೇ ತರ ಉಳಿದಿದ್ದ ಪ್ರಾಬ್ಲಮ್ಸ್ ನ ಜೊತೆಗೆ ಮಾಡ್ತಾ ಹೋಗೋಣ. ಫಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ಅಬ್ಸರ್ವ್ ಮಾಡಿ ಇಲ್ಲಿ. ಪುಟ್ x is equal to tan theta. ನೀವು you have to question yourself, ಏನಕ್ಕೆ tan theta ನೇ ತಗೋಬೇಕು? ಬಿಕಾಸ್ ವಿ ಹ್ಯಾವ್ ದ ಫಾರ್ಮುಲಾ 2 tan theta divided by 1 plus tan square theta. ಇಲ್ಲಿ ಸೈನ್ ಇನ್ವರ್ಸ್ ಇದೆ, ಇಲ್ಲೂ sin 2 theta ಬರೋ ತರ. ಇಲ್ಲಿ ಸೈನ್ ಇದ್ರೆ ಸೈನ್ ನೋಡಿ, ಇಲ್ಲೂ ಸೈನ್ ಇದೆ, ಇಲ್ಲೂ ಸೈನ್ ಫಂಕ್ಷನ್ ಇದೆ. ಇಲ್ಲಿ ಇನ್ವರ್ಸ್ ಫಂಕ್ಷನ್, ಇಲ್ಲಿ ಟ್ರಿಗ್ನೋಮೆಟ್ರಿಕ್ ಫಂಕ್ಷನ್ ಸೈನ್ ಫಂಕ್ಷನ್, ರೈಟ್? ಅವಾಗ ಮಾತ್ರ ನಾವು ಥೀಟಾ ಅಂತ ಬರೀಬಹುದು. ಸೈನ್ ಇನ್ವರ್ಸ್ ಆಫ್ ಸೈನ್ ಥೀಟಾ ಅಂತಿದ್ರೆ ಥೀಟಾ ಅಂತ ಬರೀಬಹುದು. ಬಿಕಾಸ್ ಆಫ್ ದಟ್ ಒನ್, ಸೊ ಹಿಯರ್ ಐ ಶುಡ್ ಸಿ ದಟ್ ಸೈನ್ ಫಂಕ್ಷನ್ ಅಲ್ಲಿ ಇಲ್ಲಿ ಸೈನ್ ಇನ್ವರ್ಸ್ ಇರೋದ್ರಿಂದ ಆಗ್ಲೇನೆ ಇಲ್ಲಿ ಸೈನ್ ಬರೋ ತರ ನಾನು ನೋಡ್ಕೊಳ್ಬೇಕು. ಸೊ ಬಿಕಾಸ್ ಆಫ್ ದಟ್ ಒನ್ ಐ ಹ್ಯಾವ್ ಟು ಟೇಕ್ x is equal to tan theta. ನೀವು ಅದನ್ನ ಯು ಶುಡ್ ಬಿ ಏಬಲ್ ಟು ಗಿವ್ ರೀಸನ್, ಏನಕ್ಕೆ x is equal to tan theta ನೇ ತಗೊಂಡಿದ್ದೀರಾ ಅಂತ ಹೇಳಿ, ಏನಕ್ಕೆ ಅಂತ, ದಟ್ಸ್ ಎಕ್ಸ್ಪ್ಲನೇಷನ್. ಗೊತ್ತಾಯ್ತಾ? ರೈಟ್. ಇಫ್ x is equal to tan theta, theta becomes ಏನಾಗುತ್ತೆ? tan inverse of x. tan inverse of x. ಇದನ್ನ ಇಲ್ಲಿಗೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಸ್ಟಿಲ್ ಐ ಆಮ್ ನಾಟ್ ಡಿಫ್ರೆನ್ಶಿಯೇಟಿಂಗ್, ಐ ಆಮ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟಿಂಗ್, simplifying the given function. So sin inverse of ಏನಾಗುತ್ತಪ್ಪ ಅವಾಗ 2 into x ಜಾಗದಲ್ಲಿ tan theta divided by 1 minus 1 plus x square, x tan square theta, 2 tan theta divided by 1 plus tan square theta. So ಅಲ್ಲಿಗೆ ಫಾರ್ಮುಲಾ ಯಾವ್ದು ಯೂಸ್ ಮಾಡ್ತಾ ಇದೀವಿ? sin 2 theta. sin inverse of sin 2 theta. So using this formula, sin inverse of sin theta is theta. Sin inverse of sin 2 theta is equal to 2 theta. Y is equal to 2 into theta ಅಂತಂದ್ರೆ ಏನು? tan inverse x. Replace that one. Now, so what we have done, ಈ ಫಂಕ್ಷನ್ ಅನ್ನ ಈ ತರ ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ಕೊಂಡಿದೀವಿ, ಡಿಫ್ರೆನ್ಶಿಯೇಷನ್ ಮಾಡೋದಕ್ಕೆ ಈಸಿ ಆಗಲಿ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು. y is equal to, now it is very easy to differentiate. dy by dx is equal to 2 into, ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ tan inverse x ಡೆರಿವೇಟಿವ್ ಹೇಳಿದ್ದೀನಿ. tan inverse of x derivative is 1 divided by 1 plus x square. So you can write it as 2 divided by 1 plus x square. This is the way you find the derivative, right? On screenshot ತಗೊಳ್ಳಿ, ಬೇಗ ಬರ್ಕೊಳ್ಳಿ. I'll give you a minute to write this one. Make a note of it, quick. ಏನಾದ್ರು ಡೌಟ್ಸ್ ಇದೆಯಾ ಕೇಳಿ. Is audio available now? Manoj? Aditya? Audio ಕ್ಲಾರಿಟಿ ಇದೆಯಾ? ಎನಿವನ್? ಓಕೆ, ಫೈನ್. ಏನು ಡೌಟ್ಸ್ ಇದೆಯಾ ಕೇಳಿ, ಎನಿಬಡಿ. ಎರಡು ಲಿಸ್ಟ್ ಆಫ್ ಫಾರ್ಮುಲಾಸ್ ಇದೆಯಲ್ಲ, ಆ ಎರಡು ಲಿಸ್ಟ್ನ ತಿಳ್ಕೊಂಡಿರ್ಬೇಕು ನೀವು ಬಿಫೋರ್ ಸಾಲ್ವಿಂಗ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮೆಥಡ್ ಮೇಲೆ ಪ್ರಾಬ್ಲಮ್ಸ್ ಅನ್ನ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಒನ್. ಅಲ್ಲಿ ಏನು ಸೈನ್ ಇನ್ವರ್ಸ್ ಆಫ್ ಸೈನ್ 2 ಥೀಟಾ 2 ಥೀಟಾ ಅಂತ ಬರ್ದಿದ್ದೀನಿ, ಏನಕ್ಕೆ? ದಟ್ಸ್ ಅ ರೀಸನ್. ಇಲ್ಲಿದೆ ರೀಸನ್. ಥೀಟಾಗೆ ಟ್ಯಾನ್ ಇನ್ವರ್ಸ್ ಎಕ್ಸ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ದೀನಿ. ಕ್ಲಿಯರ್ ವಿಕ್ರಮ್? ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಒನ್. ಫಾಸ್ಟ್ ಆಗಿ ಬರ್ಕೊಳ್ಬೇಕು. ತುಂಬಾ ಸ್ಲೋ ಮಾಡ್ಕೊಂಡ್ರೆ ಅವರು ಟರ್ಮ್ ಏನ್ ಸಿಲೆಬಸ್ ಕೊಟ್ಟಿದಾರೋ ಅದನ್ನ ಮುಗಿಸೋದಕ್ಕಾಗಲ್ಲ. ಲಾಸ್ಟ್ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ಏನ್ ಡೌಟ್ ಇದೆ ರೀ ಆಕಾಶ್? ಲಾಸ್ಟ್ ಸ್ಟೆಪ್ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದೀವಿ ಅಷ್ಟೇನೆ ಅಲ್ವಾ? ಇನ್ನು ಏನ್ ಡೌಟ್ ಸಾಧ್ಯ ಅಲ್ಲಿ? ಅದೇ tan inverse x ಡಿಫ್ರೆನ್ಶಿಯೇಷನ್ ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಮಾಡಿದ್ದೆ ಅಲ್ವಾ? ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಅಬ್ಸೆಂಟ್ ಆಗಿದ್ರ ನೀವು, ಆಕಾಶ್ ಅಂಡ್ ಸುಕುಮಾರ್. ಡಿಫ್ರೆನ್ಶಿಯೇಷನ್ 2 ಕಾನ್ಸ್ಟೆಂಟ್ ಇದೆ ಅಲ್ವಾ? tan inverse x ಡಿಫ್ರೆನ್ಶಿಯೇಷನ್, tan inverse x ಗೆ 1 divided by 1 plus x square. ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಡಿಫ್ರೆನ್ಶಿಯೇಷನ್ ಹೇಳ್ಕೊಟ್ಟಿದ್ದೀನಿ, ಹೇಗೆ tan inverse x ಮತ್ತೆ ನೋಟ್ಸ್ ಕಳಿಸಿದೀವಿ. ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಇರ್ಲಿಲ್ವಾ ನೀವು ಆಕಾಶ್ ಅಂಡ್ ಸುಕುಮಾರ್? ಡಿಫ್ರೆನ್ಶಿಯೇಷನ್ ಅಷ್ಟೇನೆ ಅದು. ಫೈನ್. Next one, second one. Y is equal to sin inverse of 1 minus x square divided by 1 plus x square. ಇವಾಗ ನನ್ನ ಜೊತೆಗೆ ಹಾಗೆ ವರ್ಕ್ ಮಾಡ್ತಾ ಹೋಗಿ. ಪ್ರಾಬ್ಲಮ್ ಬರ್ಕೊಳ್ಳಿ, ನನ್ನ ಜೊತೆ ಹಾಗೆ ವರ್ಕ್ ಮಾಡ್ತಾ ಹೋಗಿ. Let me see who will get the answer. ಸುಕುಮಾರ್ ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಪ್ರೆಸೆಂಟ್ ಆಗಿದ್ದೆ. ಡೆರಿವೇಟಿವ್ ಆಫ್ tan inverse x 1 by 1 plus x square ಅಲ್ವಾ? ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? ಸೊ ಅದು 2 ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ, 2 into 1 plus. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ಹೋಗಿ. ಗೋ ಫಾರ್ ದಿ ನೆಕ್ಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್. ಟೇಕ್ y is equal to sin inverse of 1 minus x square divided by 1 plus x square. Obviously ಸೇಮ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಸೇಮ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಸೊ ಇಟ್ ಬಿಕಮ್ಸ್ 1 minus tan square theta. ನನ್ನ ಜೊತೆಗೆ ಹಾಗೆ ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಹೋಗಿ. ಬಟ್ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಸೈನ್ ಇನ್ವರ್ಸ್ ಆಫ್ cos 2 ಬಂದ್ಬಿಡುತ್ತೆ, cos 2 theta. ಸೈನ್ ಇನ್ವರ್ಸ್ ಆಫ್ ಈ ಪ್ರಾಬ್ಲಮ್ಗೆ ಅಲ್ಲಿ ಫಾರ್ಮುಲಾ ಇರುವಂತದ್ದು cos 2 theta ಬರುತ್ತೆ. ಬಟ್ ಕಾಸ್ ಇದ್ರೆ ನಾವು ಇನ್ವರ್ಸ್ ಟ್ರಿಗ್ನೋಮೆಟ್ರಿಕ್ ಫಂಕ್ಷನ್ ಅಪ್ಲೈ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. ಎರಡೂ ಸೈನ್ ಇರಬೇಕು, ಇಲ್ಲ ಎರಡೂ ಕಾಸ್ ಇರಬೇಕು, ಇಲ್ಲ ಎರಡೂ ಟ್ಯಾನ್ ಆ ಥರ ಇರಬೇಕು. ಸೊ ಇದನ್ನ ವಿ ಹ್ಯಾವ್ ವಿಲ್ ಕನ್ವರ್ಟ್ ದಿಸ್ ಕಾಸ್ ಆಸ್ ಸೈನ್ by using allied angle concept. Sin inverse of sin of pi by 2 minus 2 theta, sin of 90 minus theta. Nodi, sin of 90 minus theta is cos theta, or cos theta is sin of 90 minus theta. Now I can apply this formula. Sin inverse of sin theta is equal to theta ಅನ್ನೋ ಫಾರ್ಮುಲಾ ನ ಅಪ್ಲೈ ಮಾಡಬೇಕು. ಇವಾಗ ಇಟ್ ಇಸ್ ರೆಡಿ ಫಾರ್ ಅಪ್ಲೈಯಿಂಗ್ ಬಿಕಾಸ್ ಬೋತ್ ಆಫ್ ದೆಮ್ ಆರ್ ಸೇಮ್ ಫಂಕ್ಷನ್. ಒಂದು ಇನ್ವರ್ಸ್ ಫಂಕ್ಷನ್ ಇದೆ, ಇನ್ನೊಂದು ಸೈನ್ ಫಂಕ್ಷನ್ ಅದೇ ಇದೆ. ಸೈನ್ ಇನ್ವರ್ಸ್ ಆಫ್ ಸೈನ್ ಥೀಟಾ ಅಂದ್ರೆ ಇವಾಗ ಏನು ನೋಡ್ಕೊಳ್ಳುತ್ತೆ, ಪೈ by 2 minus 2 theta ಅಂತ ಬರುತ್ತೆ. ನೆಕ್ಸ್ಟ್ y is equal to pi by 2 minus 2 into theta ಅಂತಂದ್ರೆ tan inverse x. ನೋಡಿ, ಈ ಫಂಕ್ಷನ್ ಅನ್ನ ಈ ತರ ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ಕೊಂಡಿದೀವಿ. ನೌ ಇಟ್ ಇಸ್ ರೆಡಿ ಫಾರ್ ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್. ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿ. ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದಾಗ y ಇದ್ದಿದ್ದು ಏನಾಗುತ್ತೆ, dy by dx ಆಗುತ್ತೆ, ಇಸ್ ಈಕ್ವಲ್ ಟು pi by 2 ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಏನಾಗುತ್ತೆ, 0 ಆಗುತ್ತೆ, ಮೈನಸ್ 2 ಹಾಗೆ ಇಟ್ಕೊಡಿ ಕಾನ್ಸ್ಟೆಂಟ್. 2 ಇಂಟು ಡೆರಿವೇಟಿವ್ ಆಫ್ tan inverse x ಅಂದ್ರೆ 1 divided by 1 plus x square. So final answer minus 2 divided by 1 plus x square ಬರುತ್ತೆ. So ಇದು derivative of the given problem. Okay na? Fine. Some of them are sending the answers. Swati, Manoj, right? Harshita are correct answer, right? Move on to the next one. Good. ಚೆನ್ನಾಗಿ ಮಾಡ್ತಾ ಇದ್ದೀರಾ ಹಾಗಿದ್ರೆ? ನನ್ನ ಜೊತೆಗೆ ಹಾಗೆ ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಹೋಗಿ, ಡೋಂಟ್ ವೇಸ್ಟ್ ಟೈಮ್. y is equal to sin inverse of 2x into root of 1 minus x square. Sin inverse of 2x into root of 1 minus x square. ಪ್ರಾಬ್ಲಮ್ ನೋಡಿ, ಇದಕ್ಕೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಹೇಳ್ತೀರಾ ಯಾರಾದ್ರೂ ಏನಾದ್ರು? ವಾಟ್ಸ್ ದ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್? ಬೆಸ್ಟ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ದಿಸ್ ವಿ ಕ್ಯಾನ್ ಅಡಾಪ್ಟ್ ಹಿಯರ್. ಪುಟ್ x is equal to sin theta. ಸಾಲ್ವ್ ಮಾಡಿ. ಪುಟ್ x is equal to sin theta. This implies theta is equal to sin inverse of x. Substitute ಮಾಡಿ. ನೀವು ನನ್ನ ಜೊತೆ ವರ್ಕ್ ಮಾಡ್ತಾ ಹೋಗಿ. Put x equal to sin theta. Theta implies theta is equal to sin inverse of x. So y is equal to sin inverse of. ನಾವು ಏನಕ್ಕೆ ಈ ತರ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡ್ಕೊಳ್ತಾ ಇದೀವಿ, ಈ ಫಂಕ್ಷನ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ಆಗಿರುತ್ತೆ, ಅದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿಕೊಂಡು ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಮಾಡೋದಕ್ಕೋಸ್ಕರ ಈ ಟರ್ಮ್ ನ ನಾವು ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ಕೊಳ್ತಾ ಇದೀವಿ. ಸೊ 2 into x ಜಾಗದಲ್ಲಿ sin theta ಬರಿತಾ ಇದ್ದೀನಿ into square root of 1 minus x ಜಾಗದಲ್ಲಿ sin theta ಬರೆದ್ರೆ sin square theta ಆಗುತ್ತೆ. Fine. This is equal to sin inverse of 2 sin theta. ನೋಡಿ ಇದನ್ನ ಡೈರೆಕ್ಟ್ ಆಗಿ ಬರಿತಾ ಇದ್ದೀನಿ. ಇಲ್ಲಿ ಏನಾಗುತ್ತಪ್ಪ 1 minus sin square theta ಅಂದ್ರೆ cos square theta. Cos square theta square root ಇಂದ ಹೊರಗಡೆ ಬರ್ಕೊಂಡ್ರೆ cos theta ಆಗುತ್ತೆ. Once again I am repeating, root of 1 minus sin square theta ಇದೆ. 1 minus sin square theta ಅಂದ್ರೆ from the first trigonometric identity it becomes cos square theta. Fine. Cos square theta square root ಇಂದ ಹೊರಗಡೆ ಬರ್ಕೊಂಡ್ರೆ cos theta ಆಗುತ್ತೆ. So this is equal to sin inverse of, ಇದು ಒಳ್ಳೆ ಫಾರ್ಮುಲಾ ನೋಡಿ, 2 sin theta cos theta means it is sin 2 theta. Sin inverse of sin 2 theta is 2 theta. This is equal to 2 into sin inverse of sin 2 theta is 2 theta. 2 into theta ಅಂದ್ರೆ sin inverse x. So y is equal to sin inverse x. ಈ ತರ ಇರುವಂತ ಫಂಕ್ಷನ್ ಅನ್ನ ಸಿಂಪಲ್ ಆಗಿ ಈ ತರ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡಿದೀವಿ so that differentiation ಗೆ ಈಸಿ ಆಗುತ್ತೆ ಅಂತ. dy by dx, this is equal to 2 into 1 divided by sin inverse x derivative previous class ಅಲ್ಲಿ derive ಮಾಡಿದೀವಿ 1 divided by root of 1 minus x square. That's the answer. Okay, some of you are texting it, right? Lekha, Vivekyam, fine. Root of 1 minus x square, right? Harsha, right? Good answer. Vivek, yes. What about you? Sukumar, right answer. Manoj, 1 plus x square ಬರ್ದಿದ್ದೀರಾ Manoj, it is 1 minus x square. Printing error, typing error ಆಗಿದೆ ಅನ್ಸುತ್ತೆ ನೋಡಿ, right? Hema TV, right? Yoga Jay, right? Okay, ಹಾಗೆ ನನ್ನ ಜೊತೆನೆ ವರ್ಕ್ ಮಾಡ್ಕೊಳ್ತಾ ಹೋಗಿ. ಗೋ ಫಾರ್ ದಿ ನೆಕ್ಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್. ಏನೇ ಡೌಟ್ಸ್ ಇದ್ರೂ ವಾಟ್ಸಪ್ ಅಲ್ಲಿ ನೀವು ಕೇಳ್ಬೋದು ನನಗೆ. ನೆಕ್ಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್, ಥರ್ಡ್ ಒನ್ ಆಯ್ತಲ್ವಾ? ಫೋರ್ತ್ ಒನ್, y is equal to cos inverse of 1 minus x square divided by 1 plus x square. Y is equal to cos inverse of 1 minus x square divided by 1 plus x square. So ಇದನ್ನ ನೋಡಿದ್ರೆ ಗೊತ್ತಾಗ್ತಾ ಇದೆ ನಮಗೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ x is equal to tan theta. ಓಕೆ, ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಹೋಗಿ ನನ್ನ ಜೊತೆಗೆ ಹಾಗೆ. put x is equal to tan theta, theta is equal to tan inverse of x. Next y is equal to cos inverse of x ಇರೋ ಕಡೆ tan theta ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ, ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ಇದು tan 1 minus tan square theta divided by 1 plus tan square theta ಅಂದ್ರೆ ಫಾರ್ಮುಲಾ cos 2 theta. Cos inverse of cos 2 theta ಅಂದ್ರೆ 2 theta. So 2 into tan inverse x. Y is now ready for differentiation. dy by dx, this is equal to 2 into 1 divided by 1 plus x square. ನೋಡಿ, ಫಾರ್ಮುಲಾ ಗೊತ್ತಾಗಿದ್ರೆ ಈಸಿಯಾಗಿ within few seconds you can solve this problem, such type of problem. Okay. Quick. Okay, fine. Next one, ಐದನೇದು ಹೋಮ್ವರ್ಕ್ಗೆ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ತಗೊಳ್ಳಿ. ಫಿಫ್ತ್ ಒನ್ ಈಸ್ y is equal to cos inverse of 2x divided by 1 plus x square. ಇದನ್ನ ಹೋಮ್ವರ್ಕ್ ಪ್ರಾಬ್ಲಮ್ ಆಗಿ ಟ್ರೀಟ್ ಮಾಡಿ. ಆಫ್ಟರ್ ದಿ ಕ್ಲಾಸ್ ಯು ಕ್ಯಾನ್ ಸಾಲ್ವ್ ದಿಸ್ ಒನ್. y is equal to cos inverse of 2x divided by 1 plus x square. Next, fifth one, ಇದು sixth one, y is equal to secant inverse of 1 divided by 2x square minus 1. ಪ್ರಾಬ್ಲಮ್ ಬರ್ಕೊಳ್ಳಿ, ಇಂಪಾರ್ಟೆಂಟ್ ಫಾರ್ ದಿ ಎಕ್ಸಾಮಿನೇಷನ್. ಒಂದು 4-5 ಸಲ ಈ ಪ್ರಾಬ್ಲಮ್ನ ಕೇಳಿದ್ದಾರೆ. y is equal to secant inverse of 1 divided by, ರಫ್ ಶೀಟ್ಸ್ ಅಲ್ಲಿ ಬರ್ಕೊಂಬಿಡಿ ಇದನ್ನ. ಡೂ ಐ ಥಿಂಕ್ ಬೆಟರ್. ರಫ್ ಶೀಟ್ಸ್ ಅಲ್ಲಿ ವರ್ಕ್ ಮಾಡ್ತಾ ಹೋಗಿ ನೋಟ್ಸ್ ಕಳಿಸಿದ್ಮೇಲೆ ನೀಟಾಗಿ ಬರ್ಕೊಳ್ಳೋರಂತೆ. ಸೊ ಇಲ್ಲಿ ಹೀಗೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಸಾಲ್ವ್ ಮಾಡ್ಬೋದು. ಅದ್ರ ಬದಲು ಒಂದು ಕಾಸ್ಗೆ, ಬಿಕಾಸ್ ಸೈನ್ ಕಾಸ್ ಅಂಡ್ ಟ್ಯಾನ್ ಆರ್ ಮೋಸ್ಟ್ ಫೆಮಿಲಿಯರ್ ಅಥವಾ ಜಾಸ್ತಿ ಫ್ರೀಕ್ವೆಂಟ್ ಆಗಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಯೂಸ್ ಮಾಡೋದ್ರಿಂದ ನೀವು ಇದನ್ನ ಪ್ರಾಬ್ಲಮ್ನ ಚೇಂಜ್ ಮಾಡ್ಕೊಳ್ತಾ ಇದ್ದೀವಿ ನೋಡಿ. ಸೀಕೆಂಟ್ ಇನ್ವರ್ಸ್ ಆಫ್ 1/x can be written as cos inverse of x. This is the inverse trigonometric concept which I am using here, right? Secant inverse of 1/x is cos inverse of x, right? This is actually in deleted portion. Idu deleted part alli ide, clear agi helta idini nanu. Y is equal to, so problem enagutte, secant inverse of 1/2x square minus 1 will be converted into cos inverse of 2x square minus 1. Cos inverse of 2x square minus 1. Agidya? Next, idike substitution. Now you have to start. Put x is equal to cos theta. Cos theta ne enik hakbek sir? If somebody asks you, you have to say idu 2 cos square theta minus 1 andre ಇಲ್ಲಿ cos inverse ಇದೆ, ಇಲ್ಲೂ cos ಬರೋ ತರ ನೋಡ್ಕೊಳ್ತಾ ಇದೀವಿ. cos ಯಾವಾಗ ಬರುತ್ತೆ? 2 cos square theta minus 1 ಅಂತ ಒಂದು ಫಾರ್ಮುಲಾ ಇದೆ. ಆ ಫಾರ್ಮುಲಾದಲ್ಲಿ cos 2 theta ಬರುತ್ತೆ. For that reason I am using x is equal to cos theta ಅಂತ ನೀವು you should be able to give reason. So theta is equal to cos inverse x ಆಗುತ್ತೆ. Y is equal to cos inverse of 2 cos square theta minus 1. This is equal to cos inverse of cos 2 theta ಆಗುತ್ತೆ ನೋಡಿ. ಇದು 2 cos square theta minus 1 is cos 2 theta. So cos inverse of cos 2 theta is 2 theta and y is equal to 2 into theta ಅಂತಂದ್ರೆ it is cos inverse x. Now this is ready for differentiation. Differentiate ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಬೇಕಾಗಿರೋ ಆನ್ಸರ್ ಬರುತ್ತೆ. ಸೊ ಇಲ್ಲೇ ಬರ್ದಿರ್ತೀನಿ ಅದ್ರ ಪಕ್ಕದಲ್ಲಿ dy by dx is equal to 2 into cos inverse x derivative ಏನಪ್ಪಾ? It is minus 1 divided by root of 1 minus x square. That's the derivative. Okay, fine. ಕೆಲವರು ಆನ್ಸರ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ? ಗುಡ್. Okay, next 7th one, ಒಂದು ಹೋಮ್ವರ್ಕ್ ಗೆ ಮತ್ತೆ ಪ್ರಾಬ್ಲಮ್ ಇದೆ. It is y is equal to secant inverse of 1 by 4x cube minus 3x. Right? Homework ತಗೊಳ್ಳಿ. ಅದನ್ನ put x is equal to hint x is equal to cos theta ತಗೋಬೇಕು. Okay, 2 into put x equal to cos okay. Next one, y is equal to cos inverse of 3x minus 4x cube. So put x is equal to cos theta here. Put x is equal to cos theta. Find the derivative here. Completed. Put x is equal to sin theta na cos theta na. Oh, cos theta ಆಗಲ್ಲ ರೀ, sin theta ಮಾಡ್ಕೋಬೇಕು. y ಅಂತಂದ್ರೆ sin theta ಮಾಡ್ಕೊಳ್ಳಿ. theta is equal to sin inverse of x ಅಂದ್ರೆ ಯಾಕೆಂದ್ರೆ 3 sin theta ಇದೆ, ನಮಗೆ ಈ ಫಾರ್ಮುಲಾ ಇದೆ. sin 3 theta is equal to 3 sin theta minus 4 sin cube theta. So because of that one, y is equal to, correct ಮಾಡ್ಕೊಳ್ಳಿ, ಅಲ್ಲಿ ನಾನು cos theta ಅಂತ ಹೇಳಿದ್ದೆ, ಬೇಡ sin theta ತಗೊಳ್ಳಿ. cos inverse of 3 sin theta minus 4 sin cube theta. ಓಕೆನಾ? ಸೊ is equal to cos inverse of, ಇಲ್ಲಿ cos theta ಬರುತ್ತೆ, ಇಲ್ಲಿ ಯಾಕೆಂದ್ರೆ 4x cube minus 3x ಇದೆ. ಇದಕ್ಕೆ ಈ ಪ್ರಾಬ್ಲಮ್ಗೆ x is equal to cos theta ಸರಿ ಇದೆ. 4 cos cube theta minus 3 cos theta ಅಂದ್ರೆ cos 3 theta ಬರುತ್ತೆ, ಇಲ್ಲಿ sin theta ಮಾಡ್ಕೊಳ್ಳಿ. So this becomes sin 3 theta. ಓಕೆನಾ? ಸೊ this is equal to, this can be, this must be ಅಂದ್ರೆ sin 3 theta ನ ನೀವು cos ಗೆ ಚೇಂಜ್ ಮಾಡ್ಕೊಳ್ಳಿ. cos of pi by 2 minus 3 theta. cos of pi by 2 minus 3 theta. Fine, ಆಯ್ತಾ? So y is equal to, now cos inverse of cos theta pi by 2 minus 3 theta. y dy by dx is equal to pi by 2 ಅಂದ್ರೆ 0 minus, ಇನ್ನು ನಾನು ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿಲ್ಲ, ಇದೆ pi by 2 minus 3 into theta ಅಂತಂದ್ರೆ sin inverse x. So pi by 2 ಗೆ 0 ಆಗುತ್ತೆ, minus 3 into sin inverse of x ಗೆ root of 1 minus x square. So final simplified answer is minus 3 divided by root of 1 minus x square. That's a derivative. ನೋಡಿ, ಏನೋ ಡೌಟ್ ಇದೆಯಾ? ಕ್ಲಾರಿಫಿಕೇಶನ್ ರೈಟ್? ಬಹಳ ಜನ ಟೈಪ್ ಮಾಡ್ತಿದ್ದೀರಾ. ಮನೋಜ್, ಫಾಲ್ಗುಣಿ, minus 3 divided by root of 1 minus x square. Fine. Okay. ಸಿಂಪಲ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಇದೆ, ಅದನ್ನ ಯೂಸ್ ಮಾಡಿಕೊಂಡು 9th y is equal to cos inverse of sin x. ನೆಕ್ಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ 1 ಮಾರ್ಕ್ಗೆ ಕೇಳ್ತಾ ಇರ್ತೀವಿ ಇದನ್ನ. y is equal to cos inverse of sin x. ಸಿಂಪಲ್ ಆಗಿ ಮಾಡ್ಬೋದು ಅದನ್ನ, ಒಂದು ಸ್ವಲ್ಪ ಯೋಚನೆ ಮಾಡಿದ್ರೆ. ಬರೀ ಇನ್ವರ್ಸ್ ಟ್ರಿಗ್ನೋಮೆಟ್ರಿಕ್ ಫಂಕ್ಷನ್ಸ್ ಕಾನ್ಸೆಪ್ಟ್ ಅಲ್ಲಿ ಯೋಚನೆ ಮಾಡಬೇಡಿ. See, this can be written as y is equal to cos inverse of sin x can be written as sin x right. You can take up Aditya later on. Go for the next problem. Manoj, cos sin x na cos of pi by 2 minus x ಅಂತ ಬರೀಬಹುದು. So what's the advantage? ಆ ತರ ಬರೆಯೋದ್ರಿಂದ ಏನು ಅಡ್ವಾಂಟೇಜ್ ಆಗುತ್ತೆ? ಸೊ ಪ್ರಾಬ್ಲಮ್ ನೋಡಿ ಏನು ಇಷ್ಟು ಈಸಿಯಾಗಿ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ. ಈ ತರ ಪ್ರಾಬ್ಲಮ್ ಇದ್ದಿದ್ದು now that has been converted to this by using allied angle concept and inverse trigonometric formula. So y is equal to pi by 2 minus x dy by dx is equal to pi by 2 ಗೆ 0 minus constant ಆಗಿರೋದ್ರಿಂದ 0 x ಗೆ 1 ಆಗುತ್ತೆ. So final simplified answer is -1. See how simple it is. ಸರಿನಾ? ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? ಲಾಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್. ಒನ್ ಮಾರ್ಕ್ಗೆ ಕೇಳಬಹುದು ಇದನ್ನು. Right, -1 is right answer. Next one, 10th one, the last one in this. Y is equal to cos inverse of x by 2. ಅಷ್ಟೇ ಸಿಂಪಲ್ ಆಗಿದೆ ನೋಡಿ. cos inverse of x by 2 ಅಂತ ಇದೆ. cos inverse of x by 2. Observe here. Nodi, carefully observe here. Last problem in this substitution method, which is in the deleted portions topic. Deleted portion topically there. dy by dx. See, ivaga d by dx of cos inverse x ಏನಪ್ಪ? Cos inverse of x is 1 divided minus of 1 divided by root of 1 minus x square. ಹೌದೇನ್ರಿ? Right? So ಇದನ್ನ ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನ ಇದರ ಡೆರಿವೇಟಿವ್ ನ ಇಟ್ಕೊಳ್ಳಿ. ಜೊತೆಗೆ here this is a composite function. Cos inverse of f of x ಇದೆ. f of x ಅಲ್ಲಿ ಅಂದ್ರೆ x by 2 ಒಂದು ಫಂಕ್ಷನ್ ಇದೆ. ಎರಡು ಫಂಕ್ಷನ್ ಕಂಬೈನ್ಡ್ ಆಗಿದೆ. ಟ್ರಿಗ್ನೋಮೆಟ್ರಿಕ್ ಫಂಕ್ಷನ್ ಒಂದು ಅಂದ್ರೆ ಇನ್ವರ್ಸ್ ಟ್ರಿಗ್ನೋಮೆಟ್ರಿಕ್ ಫಂಕ್ಷನ್ ಒಂದು, ಇನ್ನೊಂದು ಆಲ್ಜಿಬ್ರಾಯಿಕ್ ಫಂಕ್ಷನ್. ಟೂ ಫಂಕ್ಷನ್ಸ್ ಹ್ಯಾವ್ ಬೀನ್ ಕಂಬೈನ್ಡ್. ಸೊ ಇದರ ಡೆರಿವೇಟಿವ್ ಹೀಗೆ ಬರ್ಕೋಬೇಕಾಗುತ್ತೆ ನೋಡಿ. minus of 1 divided by root of 1 minus x by 2 whole square. Observe here carefully. Minus of 1 divided by root of 1 minus x by 2 into d by dx of x by 2. Is that clear? Because this is a composite function. Chain rule apply ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ ಇಲ್ಲಿ. Next, this is equal to minus of 1 divided by square root of 1 minus square ಮಾಡ್ಕೊಳ್ಳಿ ಇಲ್ಲಿ. x square by 4 into derivative of 1 by 2 ಅಂತಂದ್ರೆ x by 2 ಅಂದ್ರೆ 1 by 2 ಆಗುತ್ತೆ. 1 by 2 ಕಾನ್ಸ್ಟೆಂಟ್. Derivative of x 1 ಆಗುತ್ತೆ. So this is equal to minus 1 by 2 divided by, ಇಲ್ಲಿ 4 is the LCM factor. ಈ ಸ್ಕ್ವೇರ್ ರೂಟ್ ಒಳಗಡೆ 4 LCM factor. 4 minus x square. ನೋಡಿ ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? minus x square ಆಯ್ತು. ಇಲ್ಲಿ ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ತಾ ಹೋಗ್ತಾ ಇದ್ದೀನಿ ಇಲ್ಲಿ. This is equal to minus 1 by 2 divided by, ಈ 4 ನ I am writing outside the square root. ಅವಾಗ ಏನಾಗುತ್ತೆ? root of 4 minus x square, square root ಇಂದ ಹೊರಗಡೆ ಬರೆದಾಗ ಏನಾಗುತ್ತೆ? 2 ಆಗುತ್ತೆ. This 2 and 2 can be cancelled. So what is left out is minus of 1 divided by root of 4 minus x square. That is a derivative. 2 and 2 cancel ಆಗುತ್ತೆ ಇಲ್ಲಿ. ನೋಡಿ ಇನ್ನೊಂದ್ಸಲ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. cos inverse of x by 2, cos inverse of f of x ಅಂತಾಗೆ ಫಂಕ್ಷನ್, ಇನ್ವರ್ಸ್ ಟ್ರಿಗ್ನೋಮೆಟ್ರಿಕ್ ಫಂಕ್ಷನ್, ಆಲ್ಜಿಬ್ರಾಯಿಕ್ ಫಂಕ್ಷನ್ ಎರಡು ಕಂಪೋಸ್ ಆಗಿದೆ, ಕಂಪೋಸಿಷನ್ ಫಂಕ್ಷನ್. cos inverse x ಅಂದ್ರೆ minus of 1 divided by root of 1 minus, minus of 1 divided by root of 1 minus x square. x ಅಂದ್ರೆ ಜಾಗದಲ್ಲಿ x by 2 ಇದೆ. ಇದರ ಡಿಫರೆನ್ಸಿಯೇಷನ್ ಮಾಡಬೇಕು. ಇಲ್ಲಿ LCM ತಗೊಂತೆ ಅಂದ್ರೆ ಸ್ಕ್ವೇರ್ ಮಾಡ್ಕೊಳ್ತಾ ಇದ್ದೀನಿ. x square by 4 ಆಗುತ್ತೆ. ಡಿಫರೆನ್ಸಿಯೇಷನ್ ಆಫ್ x by 2 is 1 by 2. ಇಲ್ಲಿ 4 LCM, 4 into 1 is 4, 4 minus x square, minus half into minus 1 minus half ಆಗುತ್ತೆ. ಸ್ಕ್ವೇರ್ ರೂಟ್ ಇಂದ ಹೊರಗಡೆ ಬರ್ಕೊಂಡ್ರೆ 4 2 ಆಗುತ್ತೆ. 2 ಡಿನಾಮಿನೇಟರ್ ಅಲ್ಲಿ ಮತ್ತೆ ನ್ಯೂಮರೇಟರ್ ಅಲ್ಲಿ ಇದೆ, ಎರಡು ಕ್ಯಾನ್ಸಲ್ ಆಗಿ ದಿಸ್ ರಿಮೈನ್ಸ್. ಓಕೆ, ಇಸ್ ದಟ್ ಕ್ಲಿಯರ್? ರೈಟ್. ವಿತ್ ದಿಸ್ ವಿ ಕಂಪ್ಲೀಟ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮೆಥಡ್ ಆಲ್ಸೋ. ನೆಕ್ಸ್ಟ್ ವಿ ಮೂವ್ ಆನ್ ಟು ದಿ ನೆಕ್ಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್. ಅಲ್ಲಿ ಸ್ವಲ್ಪ ಸ್ಪೇಸ್ ಬಿಟ್ಕೊಡಿ, ನೋಟ್ಸ್ ಅಲ್ಲಿ ಬರೀತಾ ಇರೋ ಸ್ಪೇಸ್ ಬಿಡಿ, ಅದಕ್ಕೆ ಎಕ್ಸ್ಟ್ರಾ ಪ್ರಾಬ್ಲಮ್ಸ್ ಇದೆ, ಅದು ಇನ್ಫಾರ್ಮೇಶನ್ ಕೊಟ್ಟಿರ್ತೀನಿ ನಿಮಗೆ. inverse trigonometric functions alli. Okay. Next is an important concept which you have learnt in first year itself called logarithms. Logarithms ಬಗ್ಗೆ ತಿಳ್ಕೋಣ ನೋಡಿ. Look here. No need to write anything. ನಾನು ಹೇಳ್ತೀನಿ. Observe here. ಇದರಲ್ಲಿ ಏನೋ ಡೌಟ್ಸ್ ಇದೆಯಾ? Anybody has doubts in the last column? ಇಲ್ಲ ಅಲ್ವಾ? Fine. Okay. ಇವಾಗ ನಾನು ಹೇಳಿದನ್ನೇನೋ ಬರ್ಕೊಳ್ಳೋಕೆ ಹೋಗ್ಬೇಡಿ. Observe here. Listen to this, sir. Listen to my words. ಏನು ನೀವು? Okay, fine. ನೋಡಿ. See, if you have problems of this type, these are problems here. X is equal to 23.74 into 31 whole to the power of 1 by 3. It is difficult to multiply using ordinary multiplication method. Right? Either one problem is y is equal to 2.75 divided by square root of 40. ಈ ತರ ಪ್ರಾಬ್ಲಮ್ಸ್ ಗಳಿವೆ. ಈ ಪ್ರಾಬ್ಲಮ್ಸ್ ಗಳೆಲ್ಲ ದೇ ಆರ್ ಲಿಟಲ್ ಬಿಟ್ ಡಿಫಿಕಲ್ಟ್ ಫಾರ್ ಆರ್ಡಿನರಿ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್, ಆರ್ಡಿನರಿ ಡಿವಿಷನ್ ಮೆಥಡ್ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಸಾಲ್ವ್ ಮಾಡೋದಕ್ಕೆ ಕಷ್ಟ ಆಗ್ತಿತ್ತು. ಸೊ ವಾಟ್ ವಿ ಡೂ ಹಿಯರ್ ಇಟ್ ಈಸ್, ಸೊ ಫಾರ್ ದ್ಯಾಟ್ ಒನ್ ವಾಟ್ ವಿ ಡೂ ಹಿಯರ್ ಇಟ್ ಈಸ್, ವಿ needed a tool where we can make use of that one and make this multiplication the simpler terms. ಹೇಗೆ ಮಾಡ್ತಾ ಇದೀವಿ ಅಂತಂದ್ರೆ ಅದಕ್ಕೆ we are using this logarithmic concept. Logarithmic concept, it is called as a mathematical tool. ಇವಾಗ ಟೂಲ್ ಅಂದ್ರೆ ಏನಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೀರಾ? ಟೂಲ್ ನ ಮ್ಯಾಥಮೆಟಿಕಲ್ ಟೂಲ್ ಅಂತ ಕರೀತಾ ಇದೀವಿ. ಟೂಲ್ ಏನಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತಾ ಇದೀವಿ? ಕೆಲಸ ಸುಲಭ ಆಗೋದಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತಾ ಇರ್ತೀವಿ, ರೈಟ್? ಸೊ ಏನ್ ಕೆಲಸ ಇಲ್ಲಿ ಸುಲಭ ಆಗ್ತಾ ಇದೆ? ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ನ ಅಡಿಷನ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೊಳ್ತಾ ಇದೀವಿ. ಲಾಗ್ ಆಫ್ ಎಕ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಲಾಗ್ ಆಫ್ 23.74 ಪ್ಲಸ್ 1/3 ಇಂಟು ಲಾಗ್ ಆಫ್ 31 ಅಂತ ಕನ್ವರ್ಟ್ ಮಾಡ್ತೀವಿ. ಇದೆಲ್ಲ ಹೇಗೆ ಮಾಡ್ತೀವಿ ಅಂತ ನೆಕ್ಸ್ಟ್ ಹೇಳ್ತೀವಿ. ಸೊ ಇಲ್ಲೇನ್ ಮಾಡ್ತಾ ಇದೀವಿ? ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಅನ್ನ ಸಿಂಪ್ಲರ್ ಅಡಿಷನ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡಿದೀವಿ ವಿತ್ ದಿ ಹೆಲ್ಪ್ ಆಫ್ ದಿ ಮ್ಯಾಥಮೆಟಿಕಲ್ ಟೂಲ್ ಕಾಲ್ಡ್ ಲಾಗರಿಥಮ್ಸ್. ಸೊ ಇಲ್ಲೂ ಅಷ್ಟೇ, ಲಾಗ್ ಆಫ್ y is equal to log of 2.75 minus 1/2 into log of 41 ಅಂತ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೊಳ್ತೀವಿ. ಏನ್ ಮಾಡಿದೀವಿ ಇಲ್ಲಿ? we have converted this quotient of two function into difference of two functions. ಇಲ್ಲಿ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಆಫ್ ಟೂ ಫಂಕ್ಷನ್ ನ ಅಡಿಷನ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೊಂಡಿದ್ವಿ. ಅಂದ್ರೆ ಈಸಿ ಆಗುತ್ತೆ. ಈ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಮಾಡೋದಕ್ಕಿಂತ ಅಡಿಷನ್ ಈಸಿ, ಡಿವಿಷನ್ ಮಾಡೋದಕ್ಕಿಂತ subtraction easy. So for that one we have used this mathematical tool called logarithms. So ಏನಕ್ಕೆ ಬೇಕು ಸರ್ ಇದು ಇಲ್ಲಿ ನಮಗೆ ಅಂತಂದ್ರೆ ಈ ತರ ಪ್ರಾಬ್ಲಮ್ಸ್ ಮಾಡೋದಕ್ಕೆ ಬೇಕು. ಇಲ್ಲಿ ಡಿಫರೆನ್ಸಿಯೇಷನ್ ಅಲ್ಲಿ ವಾಟ್ಸ್ ದ ಯೂಸ್ ಆಫ್ ಸಚ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಅಂತಂದ್ರೆ, ಸಿ ವಿ ಹ್ಯಾವ್ ಎ ಪ್ರಾಬ್ಲಮ್ ಆಫ್ ದಿ ಟೈಪ್ x to the power of x. x to the power of x ಅಂತಿದ್ರೆ ಹೇಗೆ ಸಾಲ್ವ್ ಮಾಡಬೇಕು? ಅದು that can be, is my voice audible to you? Some of them are sending, they can't hear. ಕೇಳಿಸ್ತಾ ಇದೆಯೇನ್ರಿ ವಾಯ್ಸು? ರೈಟ್, ಕೇಳಿಸ್ತಾ ಇದೆಯಾ? ಫೈನ್ ಫೈನ್, ಸಾಕು. ಯಾರು ಕೇಳಿಸ್ತಾ ಇಲ್ವೋ? ನೆಟ್ವರ್ಕ್ ಇಶ್ಯೂಸ್ ಇರುತ್ತೆ. ಓಕೆ ಓಕೆ, ಆಡಿಬಲ್, ರೈಟ್. ಸೊ x to the power of x, a power x, x to the power of sin x, cos x to the power of sin x, x to the power of y. ಈ ತರ ಪ್ರಾಬ್ಲಮ್ಸ್, ಈ ತರದ್ದು ಏನಿದೆಲ್ಲ, these are all called exponential functions. If you have exponential function, then to differentiate that one we need logarithmic concept. That is the reason behind the study of logarithms. ಏನಕ್ಕೆ logarithm ಸ್ಟಡಿ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಈ ತರ ಎಕ್ಸ್ಪೋನೆನ್ಷಿಯಲ್ ಫಂಕ್ಷನ್ಸ್ ನ ಡಿಫರೆನ್ಶಿಯೇಟ್ ಹೇಗೆ ಮಾಡೋದು ಅಂತ ಕಲ್ತ್ಕೊಳ್ತೀವಿ. ಮೂಲ ಅಂದ್ರೆ ಬೇಸಿಕಲಿ logarithm is used for converting the problems involving multiplication into simpler addition and problems involving quotient or division of two function into simpler ಸಬ್ಟ್ರಾಕ್ಷನ್. ಸೊ ಅವಾಗ ಈಸಿ ಆಗುತ್ತೆ, ಅದಕ್ಕೋಸ್ಕರ ಲಾಗರ್ಥಮ್ ಯೂಸ್ ಮಾಡ್ಕೊಳ್ತಾ ಇದೀವಿ. ಸೊ ಹಾಗಿದ್ರೆ ವಾಟ್ ಈಸ್ ಲಾಗರ್ಥಮ್ಸ್ ಅಂತ ತಿಳ್ಕೊಳ್ಳೋಣ. ನೋ ನೀಡ್ ಟು ರೈಟ್ ವಾಟ್ ಎವರ್ ಐ ಆಮ್ ರೈಟಿಂಗ್ ಹಿಯರ್ ನೌ. ಇದನ್ನ ನೋಟ್ಸ್ ಕಳಿಸ್ತೀನಿ, ಅವಾಗಲೇ ಬರ್ಕೊಳ್ಳಿ. ಜಸ್ಟ್ ಲಿಸನ್ ಟು ದಿ ಕ್ಲಾಸ್. ಇದು ದಿಸ್ ಇಸ್ ಬೇಸಿಕ್ ಇಂಟ್ರೊಡಕ್ಷನ್ ಅಬೌಟ್ ಲಾಗರ್ಥಮಿಕ್. ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಹೋಗೋಕ್ಕಿಂತ ಮುಂಚೆ ಲಾಗರ್ಥಮ್ಸ್ ಬಗ್ಗೆ ತಿಳ್ಕೊಳ್ತಾ ಇದ್ದೀವಿ. ಲಾಗ್ ಅರಿಥಮ್, ದಿಸ್ ಕ್ಯಾನ್ ಬಿ ಡಿವೈಡೆಡ್ ಇಂಟು ಟು. ದಿಸ್ ವರ್ಡ್, ಒಂದು ಲಾಗ್, ಇನ್ನೊಂದು ಅರಿಥಮ್. ಲಾಗ್ ಅಂತಂದ್ರೆ ರೂಲ್, ಅರಿಥಮ್ ಅಂತಂದ್ರೆ ಸಿಂಪಲ್ ಅರಿಥಮ್ಯಾಟಿಕ್. So we have to solve arithmetic problems, we have this rule called logarithm. Simple agi you can say that one. Hagidre logarithm andre enu? What are the law of logarithms? Log eside adralli ide, what are the advantages and disadvantages ide idralli. Adanna tilkolta hogona nodi. Basic idu examination kelalla, but use ಮಾಡಬೇಕಾದ್ರೆ you should be knowing what's the fact ಅಂತ ಹೇಳ್ಬಿಟ್ಟು you should be knowing. ಅದಕ್ಕೋಸ್ಕರ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. ಫಸ್ಟ್ ಇಯರ್ ನಲ್ಲೂ ಕೆಲವು ಕ್ಲಾಸಸ್ಗಳಲ್ಲಿ ಅದ್ರ ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದಾರೆ. ಇದನ್ನ ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ, ಹೈಸ್ಕೂಲ್ನಲ್ಲಿ ಓದಿದ್ರೆ. ಇದನ್ನ ಇಂಡೆಕ್ಸ್ ಫಾರ್ಮ್ ಆಫ್ ಎ ನಂಬರ್ ಅಂತ ಕರೀತೀರಾ. ಎ ಸ್ಕ್ವೇರ್ ಅಥವಾ 2 cube is equal to 8. 2 is multiplied 3 times and the value is 8. So a to the power of x is equal to index form. Idu andre this is in the index form. ಇದನ್ನೇ ಲಾಗರ್ಥಮಿಕ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ log of m to base a, this is equal to x. This is called logarithmic form. Logarithmic form in the index form ge, index form in the logarithmic form ge ಬರೆಯೋದನ್ನ ತಿಳ್ಕೋಬೇಕು. ಎಕ್ಸಾಂಪಲ್ಸ್ ತಗೊಳ್ತೀನಿ ನಾನು. a power x is equal to m ಅಂತ ಇದೆ, ಇದು ಇಂಡೆಕ್ಸ್ ಫಾರ್ಮ್ ಕಲ್ತ್ಕೊಂಡಿದ್ದೀರಾ. ಅದನ್ನ ಲಾಗರ್ಥಮಿಕ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಈ ತರ ಬರೀತಾ ಇದ್ದಾರೆ. ಇಲ್ಲಿ ಬರಿಬೇಕಾದ್ರೆ ಬಹಳಷ್ಟು ಜನ ತಪ್ಪು ಬರೀತೀರಾ. ಇದನ್ನ ಹೇಗೆ ಬರೀತೀರಾ ಅಂತಂದ್ರೆ ಲಾಗ್ ಎಂ ಅಂತ ಬೇರೆ, ಇದು ಲಾಗ್ ಈ ತರ ಬರೆದ್ರೇನೆ ಬೇರೆ. ಇದು ಲಾಗ್ ಟು ದಿ ಪವರ್ ಆಫ್ ಎಂ ಅಂತ ಆಗುತ್ತೆ, ಅದಕ್ಕೆ ಮೀನಿಂಗ್ ಇಲ್ಲ. ಇದಕ್ಕೆ ಮಾತ್ರ ಮೀನಿಂಗ್ ಇದೆ. ಆ ಜಿ ಪಕ್ಕ ಎಂ ಬರೀಬೇಕು. ಆ ಜಿ ನ ಸ್ವಲ್ಪ ಪ್ರೊಲಾಂಗ್ ಮಾಡಿ ಇಲ್ಲಿ ಬರೀತಾ ಇದ್ದಾರೆ. ಈ ಪೊಸಿಷನ್ ಅಲ್ಲಿ ಬರೆಯೋದನ್ನ ಬೇಸ್ ಅಂತ ಕರಿತೀವಿ. ಲಾಗರಿಥಮ್ ಆಫ್ ಎಂ ಟು ಬೇಸ್ ಎ, ಅದೇ ತರನೇ ಬರೀಬೇಕು. ನೀವು ಈ ತರ ಬರೀಬಾರ್ದು. ಲಾಗ್ ಟು ದಿ ಪವರ್ ಆಫ್ ಎಂ ಅಂತ ಆಗುತ್ತೆ, ಅದಕ್ಕೆ ಮೀನಿಂಗ್ ಇರಲ್ಲ. ಈ ತರ ಬರೀಬಹುದು. ಲಾಗ್ ಆಫ್ 2 to the power of 7 ಅಂತ ಬರೀಬಹುದು. ಬಟ್ ದಿಸ್ ಶುಡ್ ನಾಟ್ ಬಿ ರಿಟನ್ ಆಸ್ ಲಾಗ್ ಆಫ್ 2 to the power of 7 ಅಂತ ಲಾಗ್ ಟು ದಿ ಪವರ್ ಆಫ್ ಅಂತ ಬರೀಬಾರ್ದು. ಈ ತರ ಬರೀಬಾರ್ದು, ಈ ತರ ಮಾತ್ರ ಬರೀಬೇಕು, ಈ ತರ ಬರೀಬಾರ್ದು. ದಿಸ್ ಇಸ್ ದ ವೇ ಹೌ ಯು ಹ್ಯಾವ್ ಟು ರೈಟ್. ಕ್ಲಿಯರ್? ಅರ್ಥ ಆಗಿದೆಯಾ ನೋಡಿ. ಸೊ ಹಾಗಿದ್ರೆ ಲಾಗರಿಥಮ್ ಅಂದ್ರೆ ಏನು ಸರ್? ಲಾಗರಿಥಮ್ ಆಫ್ ಎ ನಂಬರ್, ಇಲ್ಲಿ ಎಂ ಅಂದ್ರೆ ಒಂದು ನಂಬರ್. ಲಾಗರಿಥಮ್ ಆಫ್ ಎ ನಂಬರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎಕ್ಸ್ ಅಂತ ಹೇಳಿದೀವಲ್ವಾ. ಎಕ್ಸ್ ಎಲ್ಲಿದೆ? ಇಲ್ಲಿ ಎ ಪವರ್ ಅಲ್ಲಿ ಇದೆ, ಸರಿನಾ? ಲಾಗರಿಥಮ್ ಆಫ್ ಎ ನಂಬರ್ ಈಸ್ ದಿ ಪವರ್ ಟು ವಿಚ್ ದ ಬೇಸ್ ಈಸ್ ರೈಸ್ಡ್ ಟು ಗೆಟ್ ದಟ್ ನಂಬರ್. ದಟ್ಸ್ ದ ಡೆಫಿನೇಷನ್. ಐ ರಿಪೀಟ್ ದ ಡೆಫಿನೇಷನ್, ಕೇಳಿಸ್ಕೊಳ್ಳಿ. ಲಾಗರಿಥಮ್ ಆಫ್ ಎ ನಂಬರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎಕ್ಸ್ ಅಂತಿದೆ. ಎಕ್ಸ್ ಎಲ್ಲಿದೆ? ಪವರ್ ಅಲ್ಲಿ ಇದೆ. ಎ ಅಂದ್ರೆ ಏನು? ಬೇಸ್. ಇದು ಬೇಸ್ ಪವರ್, ರೈಟ್? Logarithm of a number is the power to which the base is raised to get that number. This is the definition, logical definition of logarithms. Logarithms definition ಅದೆಲ್ಲ ಕೊಡ್ತೀನಿ ನಾನು, ನೀವು ಈಗ ಕೇಳಿಸ್ಕೊಂಡ್ರೆ ಸಾಕು. ರೈಟ್? ಹಾಗಿದ್ರೆ ಅದನ್ನ ಎಕ್ಸಾಂಪಲ್ ಗೆ ಅಪ್ಲೈ ಮಾಡ್ಕೊಳ್ಳೋಣ. ಲಾಗರಿಥಮ್ ಅಂದ್ರೆ ಈಗ ಇಂಡೆಕ್ಸ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಇದೆ, ಇದರಲ್ಲಿ ಇದೆ ಅಂತ ಹೇಳ್ತಾ ಇದೀವಲ್ವಾ. ನೋಡಿ ಎಕ್ಸಾಂಪಲ್ ತಗೊಳ್ತೀನಿ. ಇವಾಗ ಇದನ್ನೇ ತಗೊಳ್ತೀನಿ. 2 cube is equal to 8 ಅಂತ ಇದೆ. ಇದು ಇಂಡೆಕ್ಸ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಆಯ್ತು. 2 cube is equal to 8. ಇದನ್ನ ಲಾಗರಿಥಮಿಕ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಬರೆದ್ರೆ therefore ಈಗ ಬರೀಬೋದಾ? ನೋಡಿ, log of 8 to base 2 is equal to 3. ಇದರಿಂದ ಇದನ್ನ ಬರೆಯೋದು, ಇದರಿಂದ ಇದನ್ನ ಬರೆಯೋದು ಅಂದ್ರೆ ಈ ಫಾರ್ಮ್ ಇಂದ, ಇಂಡೆಕ್ಸ್ ಫಾರ್ಮ್ ಇಂದ ಲಾಗರಿಥಮಿಕ್ ಫಾರ್ಮ್, ಲಾಗರಿಥಮಿಕ್ ಫಾರ್ಮ್ ಇಂದ ಇಂಡೆಕ್ಸ್ ಫಾರ್ಮ್ ಬರೆಯೋದನ್ನ ತಿಳ್ಕೋಬೇಕು. 2 cube is equal to 8 ಅದನ್ನ ಲಾಗರಿಥಮಿಕ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಬರೆದ್ರೆ log to the power of 8 ಅಂತ ಬರೀಬಾರ್ದು, log of 8 ಅಂತಾನೆ ಬರೀಬೇಕು. log of 8 to base 2, ಆ ಬೇಸ್ ಬರೀಲಿಕ್ಕೋಸ್ಕರ ಜಿ ನ ಸ್ವಲ್ಪ ಎಲಾಂಗೇಟ್ ಮಾಡಿ is equal to 3. ಇದನ್ನ ಇವಾಗ ಉಲ್ಟಾ ಬರೀತೀನಿ ನೋಡಿ. ಇವಾಗ log of 36 to base 6 is equal to how much ಅಂತ ಕರೀತಾರೆ. 2 ಅಂತ ಬರೀತೀನಿ ನಾನು. ಯಾಕೆ? ಬಿಕಾಸ್ ಇದು therefore ಇದು ಬಿಕಾಸ್ 6 square is 6 square is equal to 36. Because of that one, logarithm of 36 to base 6 is 2. Another example. Logarithm of 81 to base 3. Yeah, can anyone say the answer? What is logarithm of 81 to base 3? Right. He knows. Right answer. 4. Why it is so? If somebody asks you, logarithm of 84 to base 3 is equal to 4 of the Hague Bergri, because this is the reason. Idna index formal Bergri, 3 to the power of 4, this is equal to 81. Because of that reason, logarithm of 81 to base 3 is equal to 4. Right? Logarithm of 2 to base 16 equal to how much? Ivaga answer ಮಾಡಿ. Logarithm of 2 to base 16. ರಫಲ್ ಅಲ್ಲೇ ಆನ್ಸರ್ ಮಾಡಿ, ವರ್ಕ್ ಮಾಡಿ. ಹೇಗೆ ಬರುತ್ತೆ ಆನ್ಸರ್? ಏನಾಗುತ್ತೆ ನೋಡಿ. Logarithm of 2 to base 16. 4 is not the answer. Gautam, 1 by 4. Sukumar, 2 ಬರೋದಿಲ್ಲ. Rohit, 8 is wrong. Manoj, 1 by 4 is right. What is that, Kushi? Bharat ji, what is that? Hi anta type ಮಾಡ್ತಿದ್ದೀರಲ್ರಿ? Bharat ji, right? 1 by 4. Yashaswini, 1 by 4, right? Kushi, right? Right, right. Okay, okay, Kushi. You have a doubt. Try to unmute. You send the message, we'll reply. No problem. Not 1 by 8, Hema. 1 by 4 is right. Nikita, right answer. Okay, Kushi, you can send the doubt through WhatsApp. ಹೇಳ್ತಾನೆ ಇರ್ತೀವಲ್ವಾ? Okay, fine. 1 by 4 is right answer. Why? How do you agree that 1 by 4 is the right answer? Because 16 to the power of 1 by 4. 16 to the power of 1 by 4 ಅಂದ್ರೆ ಏನು ಹೇಳಿ ನೋಡೋಣ. 16 ಅಂದ್ರೆ 2 to the power of 4 ಅಂತ ಬರೀಬೋದಲ್ವಾ? Right? Why? What's the problem, Kushi? Why you are forcing us? ಎಲ್ರಿಗೂ ಅನ್ಮ್ಯೂಟ್ ಮಾಡಿರ್ತಾರೆ. Don't worry. Leave it. Don't worry. Leave it, Kushi. You can send the message, WhatsApp ಮಾಡಿ ಅಂತ ಹೇಳ್ತಾ ಇದೀನಲ್ಲ ಕ್ಲಾಸ್ ಆದ್ಮೇಲೆ, ತೊಂದರೆ ಇಲ್ಲ. If you are unable to type the answers, no problem, don't worry. Okay. Again you are continuing. Okay. 16 ಅನ್ನು ಏನಂತ ಬರೀಬಹುದು ಗೊತ್ತಾ? 2 power 4 ಅಂತ ಬರೀಬಹುದು. 2 power 4. 4 to the power of 1 by 4. This is equal to 2. So therefore, logarithm of 2 to base 16 is equal to 2. Now, next. ಹಾಗೆ ಇದನ್ನು ಹೇಳ್ತೀರಾ ನೋಡೋಣ. Logarithm of 10 to base 0.1. Logarithm of 10 to base 0.1. ಉಲ್ಟಾ ಇದೆ ರೀ. ಚೇಂಜ್ ಮಾಡ್ಕೊಳ್ಳಿ, ಸಾರಿ. Logarithm of 0.1 to base 10. Logarithm of fifth one. Answer ಹೇಳಿ. ಅಲ್ಲ ಇದೆಯಲ್ರಿ. Who is that? 2A119. How 1 by 4, how it is obtained? Message ಅಲ್ಲೇ ಇದೆಯಲ್ಲಪ್ಪ. Answer 16 to the power of 1 by 4 is 2 to the power of 4. 4 to the power of 1 by 4. 4 and 4 cancel ಆಗುತ್ತೆ ಅಲ್ವಾ? 2 ಉಳ್ಕೊಳ್ಳೋದು. ಸರಿನಾ? -1 ಅಂತ ಬಹಳ ಜನ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. ರೈಟ್, ಫೈನ್. ಓಕೆ, ದಿಸ್ ಈಸ್ -1. ಏನಕ್ಕಪ್ಪ ಅಂತಂದ್ರೆ 10 to the power of -1 is equal to 1 by 10 ಬರ್ತಾ. 1 by 10 ಅಂದ್ರೆ 0.1. So that logarithm of 0.1 to base 10 is -1. Right? Based on this example, we have laws of logarithms. ಏನೇನಿದೆ ಲಾ ಅದನ್ನ ನೋಡೋಣ ಅಂತ ಇವಾಗ ನೋಡಿ. LO SS ಅಲ್ಲ, ಇದು LAWS, laws of logarithms. Laws of logarithms. ನೋಡಿ, logarithm of, observe here, logarithm of m into n to base a, this is equal to, ಪ್ರಾಡಕ್ಟ್ ಇದ್ರೆ ಮಾತ್ರ ನಾವು ಲಾಗರಿಥಮಿಕ್ ಫಂಕ್ಷನ್ ಅನ್ನು ಅಪ್ಲೈ ಮಾಡಬಹುದು. ಪ್ಲಸ್ ಮೈನಸ್ ಇದ್ರೆ ಅಪ್ಲೈ ಮಾಡೋದಕ್ಕಾಗಲ್ಲ ಅಂತ ನಿಮ್ಮ ಮನಸ್ಸಲ್ಲಿ ಕೂತ್ಕೊಳ್ಬೇಕು ಐಡಿಯಾ ಕರೆಕ್ಟ್ ಆಗಿ. ಓನ್ಲಿ ವೆನ್ ವಿ ಹ್ಯಾವ್ ಪ್ರಾಡಕ್ಟ್ ಅಂಡ್ ಕೋಶೆಂಟ್, ದೆನ್ ಓನ್ಲಿ ವಿ ಕ್ಯಾನ್ ಅಪ್ಲೈ. ಲಾಗರಿಥಮ್ ಆಫ್ m into n is log of m plus log of n. ಸೇಮ್ ಬೇಸ್ ಇರುತ್ತೆ ಅಥವಾ ಬೇಸ್ ಏನು ಬರೀದೇ ಇದ್ರೆ ಇಟ್ ಶುಡ್ ಬಿ ಟ್ರೀಟೆಡ್ ಆಸ್ ಕಾಮನ್ ಬೇಸ್ ಥ್ರೂಔಟ್ ದ ಈಕ್ವೇಷನ್, ಥ್ರೂಔಟ್ ದಿ ಲಾ. ಲಾಗರಿಥಮ್ ಆಫ್ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ಟೂ ಫಂಕ್ಷನ್ಸ್. Next, logarithm of quotient of two function. I am repeating once again. Logarithm of product, logarithm of quotient ಮಾತ್ರ logarithmic concept ನ ಅಥವಾ law ನ ಅಪ್ಲೈ ಮಾಡ್ಕೋಬಹುದು. This is log of m divided by log of n. ಇಲ್ಲಿ ಬೇಸ್ ಬರ್ದಿಲ್ಲ ಸರ್ ಅಂತಂದ್ರೆ it should be treated as common base. ಯಾವ್ದಾದ್ರು ಬರ್ಕೊಳ್ಳಿ, no problem. Next, third one, important one, log of m to the power of n. This is equal to n into log m. N into log m. And fourth one, popularly called as change of base rule. ಅದನ್ನ ಈ ತರ ಹೇಳ್ತೀವಿ. Logarithm of n to base a ಅಂತ ಇದೆ ಅನ್ಕೊಳ್ರಿ. ಇದನ್ನ ಹೀಗೆ ಬರೀತೀವಿ. Log of n divided by log of a. ಈ ತರ ಬರುತ್ತೆ. Log of n to base a is equal to log of n divided by log of a ಅಂತ ಬರೀಬಹುದು. These are the important. ಇನ್ನು ತುಂಬಾ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮಿನೇಷನ್ಸ್ ಗೆ ಬೇರೆ ಬೇರೆ ತರ ಲಾಗರಿಥಮಿಕ್ ಕ್ಲಾಸ್ ಬರುತ್ತೆ. ನಮ್ಗೆ ಇಷ್ಟು ಸಾಕು ಎಕ್ಸಾಮಿನೇಷನ್ ಪಾಯಿಂಟ್ ಆಫ್ ವ್ಯೂ ಇಂದ. ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮಿನೇಷನ್ಸ್ ಟ್ರೈನಿಂಗ್ ಕೊಡ್ಬೇಕಾದ್ರೆ ಅದನ್ನ ಇನ್ನೂ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾರೆ. ರೈಟ್, ದೀಸ್ ಆರ್ ದಿ 4 ಲಾಸ್. ನೋಡಿ, ಇದರಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಬೇಕಾಗಿರೋದು ಇವೆರಡರಲ್ಲೂ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗಿರೋದು, ಪ್ರಾಡಕ್ಟ್ ಇದ್ರೆ ಮಾತ್ರ ಲಾಗರಿಥಮಿಕ್ ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನ ಅಪ್ಲೈ ಮಾಡಬಹುದು. ಪ್ರಾಬ್ಲಮ್ಸ್ ಅಲ್ಲಿ ಅದು ಬರುತ್ತೆ, ಅದಕ್ಕೆ ಈಗಲೇ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. ಸೆಕೆಂಡ್ ಒನ್ ನೋಡಿ, ಕೋಶೆಂಟ್ ಆಫ್ ಟೂ ಫಂಕ್ಷನ್ಸ್ ಇದ್ರೆ, ನಾನು ಅವಾಗಲೇ ಹೇಳಿದೆ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಏನಕ್ಕೆ ಲಾಗರಿಥಮಿಕ್ ಏನಕ್ಕೆ ಬೇಕಾಗುತ್ತೆ ಅಂತಂದ್ರೆ ದಟ್ಸ್ ಅ ರೀಸನ್. ದಿಸ್ ಒನ್ ಸಾರಿ ಇಲ್ಲಿ ತಪ್ಪಾಗಿದೆ ನೋಡಿ. ಲಾಗ್ ಎಂ ಮೈನಸ್ ಲಾಗ್ ಎಂ, ಸಾರಿ ಹಿಯರ್. ಕೋಶೆಂಟ್ ನ ಡಿಫ್ರೆನ್ಸ್ಗೆ ಅವಾಗಲೇ ಹೇಳಿದ್ವಲ್ವಾ, ಪ್ರಾಡಕ್ಟ್ ನ ಸಮ್ಗೆ. ನೆಕ್ಸ್ಟ್, ಲಾಗ್ ಆಫ್ ಎಂ ಟು ದಿ ಪವರ್ ಆಫ್ ಎನ್ ಇಸ್ ಎನ್ ಇಂಟು ಲಾಗ್ ಆಫ್ ಎಂ. Log of n to base is log n to log a. ನೋಡಿ, ಇಲ್ಲಿ ಅಡಿಷನ್ ಗೆ ಸಬ್ಟ್ರಾಕ್ಷನ್, ಇದೊಂದು ಕರೆಕ್ಷನ್ ಮಾಡ್ಕೋಬೇಕು ನಾನು. ಲಾಗ್ ಆಫ್ m by n ಅಂದ್ರೆ ಡಿವಿಷನ್ ಇದ್ದಾಗ ಡಿಫರೆನ್ಸ್ ಆಗುತ್ತೆ, ಪ್ರಾಡಕ್ಟ್ ಇದ್ದಾಗ ಸಮ್ ಆಗುತ್ತೆ. ದಟ್ಸ್ ಐಡಿಯಾ. ಓಕೆ, ದೀಸ್ ಆರ್ ದಿ ಲಾಸ್ ಆಫ್ ಲಾಗರಿಥಮ್ಸ್. ರೈಟ್, ನೆಕ್ಸ್ಟ್ ಈಸ್ ಇನ್ನೊಂದೆರಡು ಕಾನ್ಸೆಪ್ಟ್ ಇದೆ ಇದರಲ್ಲಿ, ಏನಂತ ಹೇಳ್ತೀನಿ ನೋಡಿ. Before going to the next one concept, logarithm of any number to same number, what it is? Logarithm of any number to the same base. Logarithm of any number to same base is 1. For example, log of 7 to base 7 is equal to 1. ಯಾಕೆ ಅಂದ್ರೆ 7 to the power of 1 is 1, 7 only. Logarithm of 20 to base 20 ಅಂತಿದ್ರೆ ಇದನ್ನ 1 ಅಂತ ಬರೀತೀವಿ. ಯಾಕೆಂದ್ರೆ 20 to the power of 1 is always 20. How they do it? Right? 20 to the power of 1 is always 1. Next. Logarithm of 1 ಏನಾಗುತ್ತೆ ಆಗಿದ್ರೆ to any base. Logarithm of 1 ಏನಾಗುತ್ತೆ? You have used it in first year. Physics allu ella kade use ಮಾಡ್ತಾ ಇದ್ದೀರಾ. Right? 0 because ಇಲ್ಲಿ a power equal to a ಇಲ್ಲಿ because a power 0 this is equal to 1. Any term to the power 0 1 alva. So ಹಾಗಾಗಿ ಇಲ್ಲಿ logarithm of example ತಗೊಂಡ್ರೆ logarithm of 1 to 7 base ಅಂತ ಇರುತ್ತೆ ಅನ್ಕೊಳ್ಳಿ. ಅವಾಗಲೂ 1 ಅಂತ ಬರೀ 0 ಅಂತ ಬರೀತೀವಿ. log of 1 to base 17 ಅಂತ ಇದ್ರೂ 0 ಆಗುತ್ತೆ. ಸೊ ಇಷ್ಟು ಕಾನ್ಸೆಪ್ಟ್ಸ್ ನ ನೀವು ಲಾಗರಿಥಮಿಕ್ ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಹೋಗೋಕ್ಕಿಂತ ಮುಂಚೆ ತಿಳ್ಕೊಂಡಿರ್ಬೇಕು. ಲಾಗರಿಥಮ್ ಆಫ್ ಪ್ರಾಡಕ್ಟ್ ಸಮ್ ಆಗುತ್ತೆ, ಡಿಫ್ರೆನ್ಸ್ ಕೋಶೆಂಟ್ ಕೋಶೆಂಟ್ ಡಿಫ್ರೆನ್ಸ್ ಆಗುತ್ತೆ, ಅಥವಾ ಈ ತರ ಇದ್ರೆ ಹೀಗೆ ಬರೀಬಹುದು. ರೈಟ್? ಈ ತರದ ಪ್ರಾಬ್ಲಮ್ಸ್ಗಳನ್ನ ಎಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ಕೊಳ್ತೀವಿ? ಆಗ್ಲೇ ಹೇಳಿದ್ವಿ, ಎಕ್ಸ್ಪೋನೆನ್ಷಿಯಲ್ ಫಂಕ್ಷನ್ಸ್ ಯೂಸ್ ಮಾಡ್ಕೊಳ್ತೀವಿ. ಎಕ್ಸ್ಪೋನೆನ್ಷಿಯಲ್ ಫಂಕ್ಷನ್ ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ಗೆ ಲಾಗರಿಥಮಿಕ್ ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ನೋಡಿ, ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಹೇಳ್ಬಿಡ್ತೀನಿ ಅದನ್ನ. ಇವಾಗ y is equal to a power x ಅಂತ ಇದೆ. Can anyone say what is the differentiation of y is equal to a power x? ಫಾರ್ಮುಲಾ ಅಲ್ವಾ ಅದು? e power x, a power x ಫಾರ್ಮುಲಾ ಎಲ್ಲ ಹೇಳಿದ್ದೀನಿ. ಫಾರ್ಮುಲಾ ಲಿಸ್ಟ್ ಕಳಿಸ್ತೀನಿ, ಅದನ್ನ ಬರ್ಕೊಳ್ಳಿ ನೋಟ್ಸ್ ಅಲ್ಲಿ ಎಲ್ಲರೂ ಹೇಳಿ. ವಾಟ್ ಇಸ್ ದ ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಆಫ್ a power x? e power x, a power x ಎಲ್ಲ ಬರ್ದಿದ್ದೀವಿ. somebody message it, a power x into log a. fine, not x into log a power x into log a. ಅದು ಹೇಗೆ ಬರುತ್ತೆ? ಲಾಗರಿಥಮಿಕ್ ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಹೇಳ್ತೀವಿ. It's not log a power x into log a, not log x. a power x into log a. Fine, correct answer. ನೋಡಿ ಇಲ್ಲಿ ಹೇಳ್ಕೊಟ್ಬಿಡ್ತೀನಿ ಇದೊಂದನ್ನ. We'll conclude today's class. Okay. Fine, a power x into log a. Now, ನೋಡಿ ಇಲ್ಲಿ ಲಾಗರಿಥಮ್ ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದೀವಿ. This is equal to log of a power x. Okay ನಪ್ಪ? log y is equal to log of a power x. ಎರಡು ಕಡೆಗೂ log ಅಪ್ಲೈ ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ. ನೆಕ್ಸ್ಟ್ ನೋಡಿ, ಈ ಲಾ ಇದೆ, log of m to the power of n is equal to n into log m. log of m to the power of n is equal to n into log m. So ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಇದು ಅಂತಂದ್ರೆ x into log of a ಅಂತ ಆಗುತ್ತೆ. ಯೂಸಿಂಗ್ ದಿಸ್ ಥರ್ಡ್ ಲಾ, ಈ ಲಾನ ಉಪಯೋಗಿಸ್ಕೊಂಡು ಇಲ್ಲೇನಂತ ಬರೀತಾ ಇದೀವಿ, log of a power x ಅನ್ನ x into log a ಅಂತ ಬರೀತಾ ಇದೀವಿ. ನೆಕ್ಸ್ಟ್ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡೋಣ. log y ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ರೆ 1 by y ಇರೋದ್ರಿಂದ dy by dx ಬರೀತಾ ಇದೀವಿ. this is equal to log a constant, retain this as it is, x ನ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ರೆ 1 ಆಗುತ್ತೆ. ಸೊ y ನ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡ್ಕೊಳ್ಳಿ, ಬಿಕಾಸ್ ವಿ ಆರ್ ಫೈಂಡಿಂಗ್ dy by dx. see, dy by dx is equal to y into log a. ಆಯ್ತಾ? what is y? y is nothing but a power x. so it is a power x into log a. This is how we apply logarithmic differentiation for exponential functions. x to the power of x, sin x to the power of x, sin x to the power of cos x. ಆ ಥರ ಪ್ರಾಬ್ಲಮ್ಸ್ಗಳಿಗೆಲ್ಲ ದಿಸ್ ಇಸ್ ದ ಪ್ರೊಸೀಜರ್. ಫಸ್ಟ್ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ಏನ್ ಮಾಡ್ತೀವಿ? we apply log on both sides. ಆಯ್ತಾ? ಇದು ಲಾಗ್ ಅಪ್ಲೈ ಮಾಡಿದ್ವಿ. ನೆಕ್ಸ್ಟ್ ಲಾಗರಿಥಮಿಕ್ ಲಾಗಳನ್ನ ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ. ಕೆಲವು ಈ ತರ ಇರುತ್ತೆ, ಕೆಲವು ಈ ತರ ಇರುತ್ತೆ. ಆಮೇಲೆ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿಕೊಂಡು dy by dx ಅಲ್ಲಿ y ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡಿಕೊಂಡು y ವ್ಯಾಲ್ಯೂನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು. ರಿಮೆಂಬರ್ ದಟ್ ಒನ್, a power x into log a is the differentiation of this one. ಫಾರ್ಮುಲಾ ಲಿಸ್ಟ್ ಎಲ್ಲ ಕಳಿಸ್ತೀನಿ, ಅದಾದ್ಮೇಲೆ ಇದನ್ನೆಲ್ಲ ಡೀಟೇಲ್ಸ್ ಕಳಿಸ್ತೀನಿ, ನೋಟ್ಸ್ ಅಲ್ಲಿ ಬರ್ಕೊಳ್ಳಿ. ಓಕೆ, ವಿಲ್ ಎಂಡ್ ಅಪ್ ಟುಡೇಸ್ ಕ್ಲಾಸ್. ಡೌಟ್ಸ್ ಇದ್ರೆ ಯು ಕ್ಯಾನ್ ಸೆಂಡ್ ಮೀ ವಾಟ್ಸ್ಆಪ್ ಅಲ್ಲಿ ಕಳಿಸ್ಬೋದು. ಥ್ಯಾಂಕ್ ಯು. ಖಾತೆ ಮಾಡಿ.
Okay, sir. Very good afternoon to all of you. Well, yesterday's class we spoke about menstrual cycle and then followed by the process of fertilization. And after fertilization, the first stage of development, what is it? Cleavage. So after cleavage, it forms what is known as the second stage is called as the blastula. So we all know that after fertilization, the zygote is going to undergo the process of development. The first development, cleavage. What is cleavage? Repeated mitotic division. What is cleavage? Repeated mitotic division of the zygote to form a number of blastomeres. Now, what are blastomeres? Nothing but daughter cells formed due to division. So, what are blastomeres? They are nothing but the daughter cells formed due to mitotic division of the zygote. Now, this entire process, what is it called? Cleavage. So, what is cleavage? The process of repeated mitotic division of the zygote to form number of cells called blastomeres. Number of cells called blastomeres. Well, when the first division occurs, two daughter cells are formed, followed by second division, 4 daughter cells, followed by third division, 8 daughter cells, followed by fourth division, 16 daughter cells are formed. Now, after that, within the zygote, the mitotic division will continue. The mitotic division will continue, resulting in the formation of a ball of cells. So, after the fourth division, what is going to happen? Within the zygote, the division will continue. The division is going to continue. The division is going to continue. So, at the end of cleavage, what is going to happen? The entire zygote has undergone repeated mitotic division to form a ball of cells. Now, this entire ball of cells is what you call it as the morula. So, at the end of cleavage, morula is going to be formed. After morula, so first stage is completed, moves on to the second stage. What is it? Blastula. The formation of blastocele surrounded by cells is what you call it as blastula. In case of humans, we call it as blastocyst. I think in the last class, yesterday's class, I gave you the, that is, I have drawn the diagram and also label. So here in the screen diagram, you can see blastocyst. So you can see a layer of cells called trophoblast is going to be present. Inside, a cavity filled by a fluid called blastocele will be seen. And towards one end, we observe inner cell mass to be present. Inner cell mass to be present. Now, as this process continues, what is going to happen is we observe this entire process, what? Cleavage and the formation of blastocyst will be completed throughout that oviduct passage. So once blastocyst is formed, it moves into the uterus. When it moves into the uterus, what is going to happen? The next most important process, what is it? Implantation will be completed. What is implantation? Attachment of blastocyst to the wall of the uterus. Attachment of blastocyst to the wall of the uterus is what you call it as implantation. So after blastocyst stage, what is the next thing? Development process continues. What is going to happen? The blastocyst will get attached to the wall of the uterus, and that process is what you call it as implantation. Now, during implantation, what do we observe? We observe that some of the uterine tissue, the layer of the uterine tissue, the cells are going to be removed or it disintegrates, we say. The uterine tissue will disintegrate. The uterine tissue will disintegrate. Now you may ask, why should the uterine tissue get disintegrated? Please remember, I'm just drawing diagram just to understand. Okay. Now the blastocyst moves into the uterus. So let us say, we all know that the uterine endometrium has become thick. So the process of implantation should occur. So then what is going to happen? Anywhere in any part of the uterus, the blastocyst can be attached. Remember, implantation, the process of implantation can occur inside the uterus at any part of it. Now it can get attached here, it can get attached here, or it can get attached here also. The entire uterus, the layer endometrium has become thickened. Now let us say it's going to get attached at this region. So what is going to happen? The uterine tissue here gets disintegrated. The uterine tissue gets disintegrated. When it gets disintegrated, you'll find a depression is going to be formed. So what is going to happen? The blastocyst will come and lodge itself inside this. Okay, it gets lodged inside the depression. So what is going to happen? The blastocyst is going to be surrounded by uterine tissue. Now this is what you call it as embedding of the blastocyst to the wall of the uterus, and that process is called as implantation. Okay, so that means cleavage is finished, blastocyst is formed. So after blastocyst formation, what is going to happen? It travels into the uterus. Now in any part of the uterus, implantation can be get completed. So at the time of implantation, what is going to happen? Some of the uterine tissue, okay, where it is going to be embedded, at that region, the uterine tissue disintegrates and allows the blastocyst to get attached, So then what is going to happen? The blastocyst is going to be surrounded by the uterine tissue. It is going to be surrounded by the uterine tissue, and this completes the process of implantation. Now, once implantation is completed, it follows what is known as pregnancy. So that begins the mark, or it marks the process of, or you can say pregnancy begins after the process of implantation, or simply implantation indicates the beginning of pregnancy. It marks the beginning of pregnancy, or it indicates the process of pregnancy. Okay, now let us look into continuation, pregnancy and embryonic development. Now, I said the blastocyst is going to be attached to the wall of the uterus. You can see that. Okay. Now, at this region, what is going to happen? Finger-like projection at that region, finger-like projection is going to be formed. Formed from where? From the trophoblast layer. Okay. Always remember, we know that trophoblast is the outermost layer, blastocele and inner cell mass. Okay. So from the trophoblast layer, what is going to happen? We observe that finger-like projection is going to be formed. Now this finger-like projection, okay, gets connected with the uterine tissue, and that structure, that finger-like structure, what is formed, okay, between the blastocyst and the uterine wall is what you call it as chorionic villi. What is it called? Chorionic villi. What is chorionic villi? It is finger-like projection formed from the layer of trophoblast. Or you can say it's going to be formed from the trophoblast layer. Finger-like projection is going to be formed from the trophoblast layer, which is called as chorionic villi. What is it made up of? The chorionic villi is represented by uterine tissue. Small amount of uterine tissue is present. Along with that, maternal blood. Of course, we all know that uterine endometrium, uterine tissue, along with that, blood vessels are also going to be present. So they both together, okay, they put together and they form a definite structure, what is known as the chorionic villi. Now here, as pregnancy continues, as you all know, in case of human beings, what is the gestation period? It's going to be 9 months. The gestation period is going to be 9 months. And we all know that internal development, 9 months, and it is going to be internal development. So naturally, the food is going to be supplied from the mother. So naturally, there should be a connection between the mother and the developing fetus, right? So in the initial stages of pregnancy, the chorionic villi is going to supply nutrition to the developing fetus. In the initial stages of development or pregnancy, chorionic villi, which is made up of uterine tissue and maternal blood. What is it going to do? It's going to provide nutrition to the developing fetus. Now, as the fetus grows, naturally, nutritional requirement will also increase. Okay, what did I say? Chorionic villi is going to be for the initial stages. Okay, chorionic villi is going to be for the initial stages of development. When in the initial stages, chorionic villi is sufficient for supplying the nutrition. As the fetus develops, what is going to happen? The nutritional requirement also increases. Then this structure is not going to be helpful. It will not be sufficient to supply the necessary nutrition. So then what is going to happen? This chorionic villi itself transforms into another definite structure. It transforms into another definite structure, what you call it as the placenta. Now, what is placenta? It is an organic connection between the developing fetus and the mother. What is placenta? An organic connection between the mother and the developing fetus. What is the placenta made up of? I have already mentioned the chorionic villi is going to be transformed into the placenta. So naturally, what is it made up of? It shows the presence of chorionic villi and some more, okay, more amount of uterine tissue is going to be put together and they form a definite structure, what is known as the placenta. So what is the definition of placenta? A 1-mark question can be asked. What is placenta means? It is nothing but an organic connection. Please remember, you have to define placenta as an organic connection between the mother and the developing fetus. It's an organic connection between the mother and the developing fetus. Well, placenta is very, very important. It's an important structure. Why it is important? Because it provides the necessary nutrition, okay, and also helps in all other function between the mother and the developing fetus. Okay, that's the reason we say internal development. There is maternal care during pregnancy also, and after pregnancy also there is a maternal care. So during the course of development inside the mother's womb, the fetus is going to be provided with all the necessary things. So here, placenta function is very, very important. And you can see in most of the question paper mention the placental function. There are 4 important functions. What is the 4 important function of placenta means? The first function, what does it mean? What is the first function of placenta? Very important. Oxygen and food or nutrients, you can say. Oxygen and nutrients, or you can simply say the nutrients and oxygen is supplied, is going to be supplied to the developing embryo. So, exchange of oxygen and nutrients between mother and fetus. That's a function. So, what is the first function? It is going to help in supply of oxygen and nutrition to the developing embryo. From where? From the mother. So, what is the first function of the placenta? It is going to help in oxygen. It's going to help in oxygen plus nutrient supply to the embryo. Oxygen and nutrient supply to the embryo. Second function, very important. It is also going to help in removal of carbon dioxide and excretory waste. Please do not write it as, okay, here, very important. First is, it's a supply of oxygen and nutrients to the embryo. From where? From the mother to the embryo. Second, removal of what? Carbon dioxide and excretory waste. From where? From the embryo. From the embryo. So this removal is going to be from the embryo to the mother. It is going to be from the embryo to the mother. Third one, it is also going to help in transport, or you can say exchange of all substances. It's going to be exchange of all substances between the mother and the embryo. Exchange of all substances, anything and everything is going to be exchanged between the mother and the embryo through the placenta. And lastly, most important, placenta is endocrine in function. It's going to be endocrine in function. What do you mean by endocrine? The placenta also has the capacity to produce hormones. So whenever we say, when we use this word endocrine means, remember endocrine gland secretion is always hormones. Exocrine gland secretion will always be enzymes. Keep this in mind, okay? This distinction you should have. So when we just very plainly, when we say placenta is going to be endocrine in function means, what does that mean? What does it mean? It means that the placental cells has the capacity to produce hormone, Hence we say placenta performs endocrine in function. So these are the 4 important functions performed by placenta. So initial stages of development, chorionic villi is sufficient to transport the nutrients to the developing embryo. The chorionic villi is formed by uterine tissue and maternal blood. So on the trophoblast layer, finger-like projections can be seen. This finger-like projection is what you call it as the chorionic villi. Initial stages, chorionic villi is sufficient for supplying nutrition to the developing embryo. But later, what happens is the nutritional requirement increases because the embryo is developing. So naturally, nutrition requirement increases. Then what is going to happen? Along with this chorionic villi, some more of the uterine tissue gets attached and they form a definite structure, what is called as the placenta. So what is placenta? It's an organic connection. What is placenta? It's an organic connection between the developing fetus and the mother. What is placenta? It's an organic connection between the developing fetus and the mother. We observe that placenta performs the following function. It's going to take part in the following function. So what are the functions? The first function, it is going to help in supply of oxygen and nutrients from the mother to the developing embryo. It's going to supply oxygen and nutrients to the embryo, to the developing embryo. Second, it is going to help in removal of carbon dioxide. It is going to help in removal of carbon dioxide and excretory waste from the embryo. It's going to help in removal of carbon dioxide and excretory waste from the embryo. What is the third one? It is going to help in transportation or exchange of all substances between the embryo and the mother, between the mother and the embryo. Last function, very important, the placental cells become endocrine in function. What do you mean by endocrine in function? They have the capacity to produce hormones. They start producing certain hormones, which is very, very important for the development of the embryo, for the maintenance of the pregnancy, for all the functions which is going to be taking place inside the mother and also in the embryo. So these hormones play an important role. Okay, so that's about functions of placenta. As I mentioned, these functions of placenta can be generally asked for a 2-mark question. Why 2-mark question? Because there are 4 functions. Okay, clear 4 functions are performed by the placenta. Okay, now let us take the last function. What is it? Placenta secretes hormones. Okay, what are the hormones it is going to produce? Now let us look into the hormones produced by the placenta. What are the 4 hormones? Number 1, it's called as HCG. Second, you call it as HPL. Third one, estrogen. The fourth one, progesterone. Okay, and the last one, you call it as relaxin. But relaxin is going to be secreted from the ovary. Relaxin is going to be secreted from the ovary. So how many hormones produced by the placenta? The following. What is the first one? Human chorionic gonadotropin. HCG, full form, human chorionic gonadotropin. Second, HPL, human placental. 1 minute. It's okay. 1 minute. I'll just. Okay. The third one, the 2 other hormones are very common. What is it? It's going to be estrogen and progesterone. As you all know, estrogen and progesterone is commonly, sorry, I had a little confusion. So HPL is nothing but human placental lactogen. Human placental lactogen. The third one, estrogen, a common hormone generally produced in the female body. Progesterone, as we all know, during pregnancy, the hormone is going to be continuously produced. Okay. Then last hormone, what is it? Relaxin. All these 4 are going to be synthesized from the placenta. Whereas the last hormone, what is it? Relaxin. Okay. Relaxin is going to be produced from the ovary. It is going to be produced from the ovary. Again, these 2, all these can be asked for a 2-mark question. Mention the hormones produced from the placenta. Mention the hormones produced from the placenta. So, functions of placenta is important, and also the hormones produced from the placenta is important. What are the hormones? HCG, HPL, estrogen, progesterone, and relaxin. HCG, human chorionic gonadotropin. What is HPL? Human placental lactogen. Third one, estrogen. Fourth one, progesterone. And the last one is going to be relaxin. Now, relaxin is going to be secreted from the ovary, and generally relaxin is going to be produced at the end of the pregnancy. During the 9th month, this hormone is going to be produced. Another important, what is it? We observe that HCG, HPL and relaxin. Okay, what is it? HCG, HPL and relaxin. These 3 hormones, what are they? HCG, HPL plus relaxin. These 3 hormones are going to be produced only during pregnancy. So during pregnancy only these hormones presence can be seen. Okay, what is it? One is HCG, human chorionic gonadotropin. What is the second one? Human placental lactogen. What is the third one? Relaxin. So these 3 hormones are going to be produced only at the time of pregnancy. Whereas we all know estrogen and progesterone is normally secreted. Okay, they are normally produced. As I mentioned, relaxin is going to be produced during the end of the gestation period, and it is going to be secreted by the ovary. Well, now this is the functions of placenta and what are the hormones it is going to be produced. Now, as I mentioned, hormones play an important role. What is the important role? They definitely influence the all developmental process taking place in the embryo. And also it influences the metabolic activity. Definitely it brings about the changes in the metabolic activity. Totally, at the end of it, what do we observe, Andre? The maintenance of the pregnancy is definitely going to be by the hormones. Now, these are the few hormones I have mentioned. Of course, we also observe that there are other hormones also produced during pregnancy. And what is going to happen? We observe that the overall developmental process is influenced by the hormones. Now, let us say development process is completed. So we know that in case of humans, the pregnancy is going to be lasting for about 9 months. What is this 9 months? It is nothing but the gestation period. It is nothing but the gestation period. How many days? It's going to be 280 days. How many weeks? It's going to be 40 weeks. So you can say 9 months is the gestation period. Gestation period is going to be about 280 days, or we can also say the gestation period is around 40 weeks. Now, generally, we also observe that, okay, sometimes during the 37th week itself, the fetus is going to be delivered. Then we call it as premature delivery. We call it as premature delivery. Now, you may question, within that period, please remember, the complete development is already taken place. There may be partial, a very little amount of development to be completed, but due to certain conditions, what is going to happen? Parturition can also occur during the 37th week. Okay, but normally 9 months is going to be the gestation period, or you can say 280 days, or you can say 40 weeks. You can also say 40 weeks. Now, after the 40 weeks, what is the next process? What is going to take place? It's nothing but parturition. What is the definition of parturition? Delivery of baby. What is parturition? You can just simply define it as delivery of baby. You can always just simply say that delivery of baby will occur. Okay, so that means at the end of 9th month, what is completed? We observe that parturition will occur under the influence, once again, under the influence of the hormones. Okay. Meanwhile, let us look into, okay, another very important 5-mark question can be asked. Related to what? Related to the development during that 9 months, or in every month, what changes does it take place? So here, what do we observe? Here, what do we observe means, well, one more point to be mentioned here. We all know that the inner cell mass, okay, is what is going to help in the developing of the embryo. So we know that blastocystally, trophoblast is going to be the outer layer, blastocele ide, matte mass of cells which is referred as the inner cell mass. So this inner cell mass only will differentiate into the embryo. Now, when it is going to differentiate into the embryo, after cleavage, after blastula, the next process we call it as the gastrula. So during gastrulation, there is the development of, or you can say, there is the formation of primary germ layers. There is the formation of primary germ layers. Now, why it is called primary germ layers, Andre? When during the developmental stages of the embryo, the first 3 layers which is going to be formed are only these layers, and that's the reason it is referred as the primary germ layers. So the inner cell mass which is going to differentiate into the developing embryo will give rise to the 3 layers. What are they? Namely ectoderm, endoderm and mesoderm. 3 primary germ layers: ectoderm, endoderm and mesoderm. Why are these so important? Reason is, only after these 3 layers are going to be formed, what is going to happen? These 3 layers will further undergo differentiation to form the different types of tissues and organs in the body. So definitely, during the course of the development of the embryo, these are the 3 layers which are going to be formed. What are they? Ectoderm, endoderm and mesoderm. From where? They're going to be originating from the inner cell mass. Why is the primary germ layers important? Reason is, these are the first 3 layers which is going to give rise to the tissues and organs. The ectoderm layer will give rise to certain tissues, endoderm layer will give rise to certain tissues, mesoderm layer will give rise to certain tissues. So the different tissues and organs in our body will be developed from the primary germ layers, namely ectoderm, endoderm and mesoderm. Well, in the inner cell mass, there are some special cells. What do you call them as? You call them as the stem cells. Okay, this is again a 1-mark question, and I'm sure you might have come across this word called stem cell therapy. Okay, especially in recent medical treatment, this is one of the advanced techniques for treating certain type of diseases, or any kind of infection or any kind of damage. Stem cell therapy is one of the treatment in the medical field, which is at present very popular. But of course, it is very costly also. Okay, it is very costly also, but there are definite results for certain types of treatment. So this is also one. Now, what are stem cells? What do we observe is, in the inner cell mass, there are certain cells. There are going to be certain cells which have the capacity, which have the potency to develop completely into the tissues and organs. Okay. Now, for example, let us say we all know that many of the human population alcohol addiction anta ಹೇಳ್ತೀವಿ, right? Now, due to consumption of alcohol continuously, what is going to happen? The first organ which is going to be damaged means it is going to be the liver. Okay. Any alcohol addiction person, the first organ, you may ask, Miss, why not the stomach? Definitely, even the stomach is going to be damaged. Okay. But we all know that how important is liver to our body, because major functions of our body is going to be performed by the liver. It is not just one function. If you Google search what is the liver function, Andre, you will find it's more than 15 functions it is performing, right? So when it is performing so many functions, naturally it's an important organ. Okay, or we can simply say alcohol detoxification occurs in the liver cells. So for a long time, when this process is taking place, what is going to happen? The liver cells are going to be damaged. So then through stem cell therapy, we can also induce the formation of the new liver cells. This is one example I'm giving. So like this, in any part of our body, if the cells are going to be damaged, Andre, definitely we can, okay, we can identify, take out, that is, we can go in for a stem cell therapy. Well, that's about the inner cell mass. Okay, that's very important. Reason is it's going to give rise to the embryo, and it's going to differentiate itself into the primary germ layers. And then you will find from the primary germ layers, we observe that the various tissues and organs are going to be formed. Okay. Now, during that course of gestation period, what happens? Very important. 5-mark question can be asked. What is that 5-mark question? Explain. What is that 5-mark question which can be asked? Means explain. What is it? Embryonic development in human. Explain embryonic development in human. Or another common question. What are the features of embryonic development at various months of pregnancy? ನಿಮ್ಮ NCERT textbook ಅಲ್ಲಿ ಇದು question ಅಂತಾನೆ ಇದೆ, followed by a paragraph which gives the detailed explanation. Okay, so common ಆಗಿ ಇದನ್ನ 5-mark question ಗೆ ಕೇಳಬಹುದು. Okay, common ಆಗಿ ಇದನ್ನ 5-mark question ಆಗಿ ಕೇಳಬಹುದು. So what is the question? I repeat, what are the features of embryonic development at various months of pregnancy? Or simply explain embryonic development in human. Well, let us look into what do we know. As I've already mentioned, the gestation period is 9 months, or it can be 280 days, or it can be 40 weeks. It can be 40 weeks. Now let us look into during, that is end of, okay, end of the first month. What do we observe? We observe that in the embryo, heart is going to be formed. The end of the first month, okay, which organ we observe which is going to be formed first? It is going to be the heart. Okay, end of the second month, what do we observe? We observe limbs and digits are formed. Limbs and digits are going to be formed. Well, at the end of the third month, at the end of the third month, what do we observe? Major organ systems are formed. Okay, major organ system is formed. Well, here I would like to give information. This 9 months of the gestation period is divided into 3 trimesters. The first 3 months is referred as the first trimester. The second 3 months is referred as the second trimester. The last 3 months is referred as the third trimester. Okay, so first 3 months, first trimester. Second 3 months, second trimester. The last 3 months is referred as the third trimester. Okay, so what do we observe? End of the first month, heart is going to be formed. End of the second month, limbs and digits are formed. End of the third month, major organ system is going to be formed. So that means at the end of the first trimester, What do you mean by end of the first trimester? At the end of the third month, what all organs are going to be formed? We observe heart is formed, limbs and digits are formed, and major organs are also going to be formed. Followed by the second, or you can also say here it is going to be the, okay, end of the fifth month. Okay, end of the fifth month, what do we observe? We observe the first movement. The embryo is going to be moving inside the womb. Okay, that is why we say first movement. And then next is, we also observe hairs are going to be formed in the head region. That is the end of the fifth month. Well, end of the sixth month, what do we observe? The body is going to be covered by, the entire body is going to be covered by hairs. We also observe that eyelids will separate. Eyelids are going to be separated and eyelashes will be formed. Eyelashes are going to be formed. So end of sixth month, what do we observe? The entire body is going to be covered by hairs. The eyelids are going to separate, and we also observe that eyelashes are going to be formed. Eyelashes are going to be formed. Well, at the end of the ninth month, what do we observe? The embryo is completely developed. The embryo undergoes the complete developmental process. By the end of the ninth month, the complete development is going to be over. So here, during the various months, what are the features we observe? What development? So the end of the first month, what is it formed? Heart is formed. End of the second month, limbs and digits are formed. End of the third month, major organ system is formed. End of the fifth month, first movement, hairs on the head is going to be seen. End of the sixth month, on the body, hairs are going to be covered. Eyelids separate, eyelashes are going to be formed. And end of the ninth month, what do we observe? The entire embryo has completely developed and it is ready for the process of parturition. As I mentioned, this can be asked for a 5-mark question. It can be asked for a 5-mark question. Well, when you're talking about parturition, what is parturition? Delivery of baby. What is parturition? It is nothing but delivery of baby. Okay, so we're coming to the last part of the topic, that is parturition and lactation. I've already mentioned here what is meant by parturition means it is nothing but delivery of the baby. So what is going to happen? We observe that various hormones, okay, parturition and lactation. Parturition and lactation. So what is the meaning of parturition? It is nothing but delivery of the baby. So after the fetus is fully formed, what is going to happen? It is going to be delivered. So this process is what you call it as the parturition process. Well, here what do we observe? The process of parturition is neuroendocrine. So there is what is known as neuroendocrine mechanism. What do you mean by neuroendocrine mechanism? There is the control of neurons and also endocrine. So that means nerves plus the hormones together is going to help in the process of parturition. It is going to help in the process of parturition. In this, what is going to happen is the parturition, initiation of parturition is going to be, okay, the signals are going to be originating from the fully developed embryo. Please remember, by the end of 9th month, what is going to happen? The fetus is completely developed. So what is going to happen? We observe that the fetus, the fully completely developed fetus is going to send a signal. Where? To the brain. Okay, it is going to send the signal to the brain. So signals from the fetus, okay, signals from the fetus and the placenta. Okay, signals from the fetus and the placenta will initiate the process of parturition, or you can say it is going to send the signal for the function of parturition. So naturally here what do we observe? This kind of a signal what has been sent by the fully developed fetus. Okay, so here what do we observe? Signal from the placenta plus fully developed, okay, signals from the placenta and fully developed fetus, okay, will what happen? They are going to induce mild contraction. So initiation of the parturition, it is going to induce mild contraction. What is this called as? It is referred as fetal ejection reflex. What is it called as? Fetal ejection reflex. What is ejection? Release, expelling out. Ejection means expelling out. So naturally, the fully developed fetus have to be released to the outside. So naturally, the signals have to be sent to the brain. So that first signal, initially, the signal is going to be coming from the placenta along with the fully developed fetus. They are going to induce mild contraction. So that means these signal will go to the brain, and from the brain, the response is going to be given, and it is going to induce what is known as a mild contraction. Remember, I said it is neuroendocrine mechanism. What do you mean by neuroendocrine mechanism? The entire process of parturition is controlled and coordinated by the nerves and hormones. The entire process of parturition is controlled and coordinated by neuroendocrine mechanism. Okay, so initially the signals is going to be sent from the placenta and the fully developed fetus. So what is going to happen? It results in a mild contraction. Now what is this referred as? It is referred as fetal ejection reflex. So that means for the purpose of parturition, a very important hormone, what is it? Oxytocin. Please remember, oxytocin, along with that relaxin. I already mentioned relaxin is going to be secreted from the ovary. So at the end of the pregnancy, relaxin is going to be influencing the relaxation of the uterus, and also the contraction is also going to be, contraction and relaxation is going to be influenced by oxytocin. So oxytocin is a very important hormone which is going to help in parturition. How does it help in parturition? It is going to influence alternative or rhythmic contraction and relaxation of the uterus. So what is the use of oxytocin? It's a very important hormone produced at the end of the pregnancy along with relaxin. But most important function of oxytocin is it is going to influence the process of parturition. How does it influence the process of parturition? Means it is going to help in rhythmic contraction. It is going to help in rhythmic contraction and relaxation of the uterus, thus helping in delivery of the baby. Please remember, once the process of parturition is completed, simultaneously at the same time, what is going to happen? The mammary gland becomes functional. Remember, during the process of the pregnancy, course of pregnancy also, we observe mammary gland also undergoes certain changes. But at the end of parturition, after parturition, what is going to happen? The mammary gland becomes functional. What do you mean by functional? It's going to start producing the milk. Okay, it is going to start producing the milk. And this process is what you call it as lactation. That process is what you call it as the lactation. So what is lactation? At the end of, or you can say after parturition, the mammary gland will become functional. When you say functional means what does it do? We observe that the mammary glands will start producing the milk. And this process is what you call it as the lactation. And very important, the first milk what is produced is referred as colostrum. Please remember, after parturition, immediately the mammary gland becomes functional. It starts producing. So the first initial 3 days of milk secreted from the mammary gland is referred as colostrum. It is referred as colostrum. It's very important. Now the question is, why is it so important? Reason is the colostrum contains large amounts of immunoglobulins. I'm sure all of you all know that in our body, highest immunity provider are immunoglobulins. Okay, immunoglobulins provide us the highest immunity against any infection or any diseases. So here what happens is, in the colostrum, what do we observe? Large amount of immunoglobulins are going to be present. Now, since it contains large amount of immunoglobulins, what does it do? It provides immunity. So naturally, the first 3 days of milk secreted by the mammary gland, okay, should be fed to the newborn. It should be given to the newborn. Now, why it should be given to the newborn? Reason is it contains large amount of immunoglobulin, which is going to provide immunity to the newborn. It's going to provide immunity to the newborn, and that's the reason colostrum is very, very important. Now, we all know in India, there are a lot of myths, okay, or misconceptions we say, which is not true, okay. The fact is, it is not very much true. So, in most of the time, what do they say is, this initial milk secreted from the mammary gland is not good for the newborn. Even today, what do we observe is, in many parts of the rural area, we observe that the newborn babies are not fed by this milk, colostrum. One of the reasons is they feel that that milk is not good for the newborn. But scientifically, it is proven, medically, it is proven that colostrum contains a lot of immunoglobulin, which is going to provide immunity to the newborn baby. So naturally, it is very, very important. Now, along with this, a very important factor, the medical fraternity is making it compulsory, or you can say it is mandatory that, okay, breastfeeding should be compulsory. Why? The milk provided from the mammary gland definitely, okay, definitely is essential for the newborn and also for the development of the newborn. Of course, it has got a lot of essential nutrients required for the development of the newborn. Along with that, most important, it provides immunity. Now, we all know that we have been seeing, okay, the disease called COVID-19. Now, how does COVID-19 we can prevent? Means only by enhancing our immunity. If our immunity in our body is very good, means naturally we can fight COVID-19 virus. So that means by nature itself, in the colostrum, immunoglobulins are going to be more. So that means it is important that colostrum to be fed to the newborn. Okay, so with that, we complete with the topic what is known as human reproduction. Well, I will definitely recommend to all of you, open your textbook and first, okay, go through all the information what is given in the textbook. And behind your textbook also, there is a concise summary of this topic. Along with that, there are some questions are also given. Okay, so try to read the information, read the summary, and also try answering those questions which has been given at the end of the chapter. Meanwhile, by the time, okay, when I come for the next class, there will be, okay, I shall give the notes and also along with that questions which are commonly appearing in your annual examination, and certain CET and NEET level questions will also be shared with you all. So that we shall discuss in the next class. Thank you all. ಒಂದು 100 ಜನ ಎಲ್ಲ ಕ್ಲಾಸುಗಳು ಅಷ್ಟೇ